Greetings, everyone. You have joined the fourth ICADS International Conference on Applied Data Science, being hosted by Area 4, Region 6 of the IEEE Computer Society and organized by the Santa Clara Valley chapter of the IEEE Computer Society. I'm Vishnu Pendyala, the Area 4 Region 6 coordinator and the chapter chair of the Santa Clara Valley chapter. Situated in the Silicon Valley, our chapter holds a unique position due to our strategic location and wealth of expertise and audience available to us. So today's event is also co-hosted by 23 other chapters. You see them on this slide. ICADS 2025 brings together leading experts and innovators from around the globe. So this year's focus is on Agentic AI systems that exhibit autonomy, initiative, and adaptability. Sessions will include Gen AI applications, panel discussions, and presentations on the future of intelligent systems. So just just a couple of minutes back, I tried to create this video. Let's see if it plays okay. Oh, it's missing the audio. But anyway, you get the idea. So I tried to create it using generative AI to introduce the event and also the speakers. So today's speakers include Dr. Soumen Biswas from Hitachi, Ranjita Kulkarni from Dropbox, Dr. Utku Kose from Suleiman Demirel University, Dr. Anuradha Kar from Paris, Kamar Ali Yuksel from AI Explain, and of course, you're all the speakers when you ask questions. And today's topics include Agentic AI, redefining autonomy in intelligent systems, Gen AI and large language models, real-world applications, trustworthiness, transparency, and ethical challenges, Agentic AI in healthcare, business, and science, and of course, future roadmap covering the challenges and collaboration opportunities. The event is being recorded and will be available publicly. And today's master of ceremonies is Rahul Raja from LinkedIn. And he's also the current secretary of the chapter. So Rahul, please take it away.
Hey, thank you, Dr. Vishnu, for going through the introduction. So I think we can get started with the first presentation that we have. So Dr. Soumen Biswas will be delivering a session on Agentic AI, which is redefining autonomy in intelligent systems. So Dr. Soumen, feel free to go in the presentation mode and start the presentation.
Yes. Thank you. Thank you, Mr. Raja. So let me share my screen and please confirm whether my screen is visible to you. Is my screen visible to everybody?
Yeah, we can see. Please also introduce yourself before you go through your presentation.
Yeah, sure. Okay. Thank you. Good morning, everyone. I am Soumen Biswas, working as a chief researcher in Hitachi India Research and Development Center. So I work in computer vision and AI team in Hitachi R&D Center here in India. So prior to that, I was working in ACL. R&D Center in Chennai in India, and I also work for the KLA 10 core that automotive industry for the semiconductor devices, and I completed my PhD here in computer vision. And prior to that, I was in academic. I was teaching as a assistant professor uh, in uh, in West Bengal Institute of Technology. So before that, thank you and thank you, Rahul, and it's a pleasure to be here to talk about agentic AI. So a major evolution in how intelligence system operates. Over next few minutes, we'll walk through what agentic AI is and how it works, and why it's set to redefine autonomy in AI system. So let's begin by why we are here. So artificial intelligence has entered a new phase, as we all know, and traditional AI system are reactive. They wait for input and give the output. But agentic AI is proactive. It initiates actions, reasons about its goals, and adapts to its environment over the time. In this talk, we'll explore its architecture, key features, real-time applications, and some of the important challenges we must consider. So first, the questions comes to our mind: what is agentic AI? Prior to that, artificial intelligence has come to the research field, and it has immense applications in diverse area of industry. And agentic AI is an interactive of large language models, machine learning, and enterprise automation. But unlike rule-based systems, agentic AI can think, decide, and act. So why I said about rule-based system? Because artificial intelligence models, what we develop for any of the domain like computer vision or LLM. So these are trained on the certain parameters, trained on the certain data. So these datas are trained, and the algorithm or models are rule-based systems. But in case of agentic AI, which can think, decide, and act, it sets its own goal, solve problems, and adapts even in unpredictable, unstructured environment. So think of it as an artificial intelligence that behaves more like a human assistant than a machine that just follows instructions. So now, how agentic AI work? So this slide breaks down its life cycle. First, it understands the context using large language models and machine learnings. Second, it sets goal, independently defining what it wants to achieve. The third one, the it comes for the execution. The AI performs the necessary task, often without needing human involvement. And finally, learning. It reflects on its outcomes and improves continuously. So these loops allow agentic AI to functional more like a real-world agent capable of evolving based on experience. So just for a simple example, so most of us nowadays, we are using Chat GPT by OpenAI. So previously, just 6 to 7 months back, when we ask any question to Chat GPT, so it's think about your questions and try to answer on the parameter how it trained. But nowadays, when you ask a question, if this context is not trained, the model means whatever the context you are providing to the chat GPT, if the context is not known to, or not known to the model is trying to find out through agentic system in the web. So if you see over there, it's searching about web search. So this is nothing but nowadays the model is looks or acts like a agentic, so that it goes to the web and searching for you about the context and give you the results. So this loop basically allows the agentic AI more functional and more evolved based on the experience. So coming to the next slide, what sets agentic system apart? These three are the core traits. So first one, persistence goal. Yeah. So the first one, persistence goal orientation. In this case, they keep their long-term objective in focus and adapt their strategies to stay on track. So on track means whatever you are providing to whatever the context you are providing, they tries to find out and give you the answers or reasoning capability on that particular context itself. So here it comes. Next part is contextual awareness. So they interpret signals from the environment, not just the input, to inform their decisions. And the third one, self monitoring and regulations. So they evaluate their own actions, course correct if needed, and optimize continuously. So this blend of autonomy, adaptability, and self awareness is what make agentic AI so powerful. So there are few advantage of this. So it boosts efficiency by automating complex tasks. It scales easily to meet growing demand. It adapts the changes, and it collaborates with human, improving the decision. So now, after the collaborative with the human and improving decision, so how it improve? It basically learn a continuous learning process, what the model is learning, and it is obviously based on the data driven, and crucially it cuts costs by autonomic sources, heavy process while learning and improving over the time. So let's talk about some benefit in enterprise context. So agentic AI execute task on its own. It can respond to changing conditions in real time. It handles problem solving autonomously, even identifying risk and mitigate them without waiting for a person to intervene. And it can work with other systems, human or AI, to ensure optimal outcome. So what exactly these are the collaboration with the multi-agent collaborative way. So when we ask a question, if we get the regions from them, if we get the answer from them, we try to a human is trying to understand the answer, and then provide more context on this, so that model can get more answers, more context, and more reliable more reliable text based on the questions what you have asked, and provide you the captions, you can say, provide you the description based on the question you have asked. So this is basically a chain process, where you are asking a question, you giving the input to the model, and then model is trying to identify the things. So now this basically most suitable for the VLM, that visual language models. So nowadays all the LLMs are improving their architecture. They are trying to improve the architecture in a way, so that we can provide multiple input like vision, or maybe it is texts like NLP task, and then combine both together and give you the answer. So if you see, if you provide an image to any VLM model, so model is trying to identify the context from that image, and on that context, if you are asking something to the model is trying to provide you the answers, what answers what that model particularly see in that image. So now it's actually the functionality of the VLM. So now what if we implement this VLM into a agentic system? So agentic system may be combined with multiple data point. It may be the image, it may be the text, and it can be plugged into with different rack system. So from where you have some database, and from that database you want to extract some information, and from that information you want to collect and verify the details about the context what you have asked, and then trying to uh, uh, find out and match that context with the image. So that VLM, and then combining with the RAG, and this whole process, end-to-end process, is basically the architecture defined by the agentic system. So in the later slide, I will explain how the architecture looks like on the agentic system. But often we talk about nowadays Gen AI. So now, what is the basic difference between Gen AI, generative AI, and Agentic AI. So generative AI is great for the content creation. It responds to the input. But agentic AI goes further in that it is autonomous, goal driven, and integrates tools and APIs. So in that case, for agentic AI, it can plugged into with multiple APIs. So API can be based on a vision API, it can be a text API, it can be a RAG system from where you are trying to identify the output based on the input what you have given. So now in that case, this is whole automation autonomous system where agentic AI has a capability, that system has the capability to take the decision by its own, and then trying to give you the context based on the context what you have given. So if you see here, in case of generative AI, obviously no external tools, no real-time feed, all this can be happened. So now there is the paradigm shift where beyond this generative AI, agentic AI is generative AI is a certain domain applications, has certain domain applications, but agentic AI has a large applications across the industry. So now if you see some domain applications of the agentic AI, so customer service for the personalized support, it can be used in healthcare to manage patient records, finance for smart decision making. It may be used in transportation in autonomous vehicle and driving assistance system. So the versatility shows that the broad impact of this technology of this agentic AI come to today's era of the world where we use oftenly the AI system. We combine multiple AI models together to find out the smart things. So these basically provide the more smarter information to the model to design an architecture in such a way so that this architecture is more smart compared to the existing AI system what it has. So just for a simple example, suppose in a surveillance system, if you want to get some information, get some activity by the worker. So in a worker system, in an indoor system, suppose you have one industry applications like inside the warehouse you want to monitor the activity of the workers. So now the thing is that how the activity can be identified. So now single VLM model cannot be identify the activity and cannot be extract the activity what the worker is doing. So in that case, if you specific to the applications of this agentic AI, so first you have to probably use the rule based system. So now you have to define the different rule. So rule means you have to define, you have to teach the model what are the activities. So in that case, if you're trying to find out or extract the activities of this particular workers, so in that case you have to you have to first identify the worker, then maybe we have to identify the worker, as well as we have to list out some of the activities, and we have to put the activities list to the system, and we have to make a rule that yes, these are the kind of activities, you consider it as a violent activity, or you can list out some of the things based on the rules. But now, so this what I talked about is detection and all these things is the applications, part of applications of the computer vision. So now what if in that case, if you use a LLM model or VLM model, so if we provide this particular context, particular video feed to the VLM model, so VLM may not have much idea about that particular actions. So VLM may hallucinate the context, means what you want to get the information from that particular video feed. VLM cannot be able to provide you that information. So in that case, you have to prepare an architecture where there will be end-to-end chain or end-to-end architectural system, where you have to first combine multiple models, vision-based models, LLM models, or caption-based models, and then you have to also implement some object detection models, and all this together can be fed to the VLM model, where VLM can be more aware of all the context what you are given. So suppose if you simply provide the full video feed to that particular VLM won't be able to find out what exactly the context the user want to identify. So in that case, if you, instead of this, if you tell that by localizing the regions inside the frames, by detecting the persons, using different vision technique like re-identification or something else, after that you can use the caption based model, where after the identification of the person, the caption will come from there. So from that caption you will get more information about the particular worker, what exactly that worker are doing. So from that context you are getting more information about the scene, and then these captions you are providing to the VLM, and then you can use a prompt based system, where using the prompt itself the system can identify what exactly you want, means what the information you want to collect from there. So now here if you want to get the extraction, means you want to know the information about the worker, like worker employee ID or something like this. So in that case you may use some rack system, where the database would be stored about all the employees of the worker. From there you can get the extracted information about the employee ID by different technique, maybe identification by re-ID, and you can match this information through rag from the database, and you can get the extraction of this particular details. So this is the total end-to-end process where the agentic AI system works, and the versatility shows that the broad impact of this technology. So going forward, so some practical examples that I already explained. So, one example, so apart from this, it has real time automated data analysis, predictive supply chain analysis to the avoid disruption, and then cyber security system that detects threats on their own, and even self-healing IT system that diagnose and fix issues without human intervention. So these are the few industrial applications where agentic AI perform very well. So now what is the technical part, like how the operational dynamics of the agentic system? So as I in the earlier slide I already mentioned, like LLMs, machine learnings, all these technology basically used inside this agentic AI system. So it begins with natural language understanding for interpreting human commands, because when we are providing any command, so or prompt, so may that model not aware of this particular context. So there it begins with the natural language processing understanding, uh, NLP task, which helps to interpret human commands. Then it uses the context and knowledge, and after this the tasks are broken down into manageable steps. So broken down into manageable steps means, if you give the context to if you give the prompt to the agentic system, so now this agentic system will define the different tasks. So what are the tasks? For that particular example, we can say the task is first identification of the worker, and then find out the activity of the worker, and find out what the employee ID of this particular worker. So all these are the we can say the broken steps. So this is manageable by agentic AI system. So it execute actions by interfacing with the system or APIs, and all these small part of actions uh, are actually handled by API calls. So there would be multiple APIs through which each and every model basically fit to the agentic AI system, and agentic AI system can identify those contexts and try to give you the proper information or proper results. So then the system learns over the time and refining itself. So this is the most important part. So now how it comes. So previously in vision based model, what we have to do, for the domain specific, we have to retrain the model using the data. So even in LLM, if you say LLM model, it stay trained on large amount of data. So if I considered the Quan model or Anthropic Claude, so they are trained on the certain amount of data, or not certain amount, a certain specific domain amount of domain specific data. So now what if I provide a say example, a flowchart image to the model, and I ask the VLM to extract this flowchart into a mermaid format. So now what VLM look into this, VLM look into that particular flowchart, and it tries to extract the information from there. But most of the VLMs are not trained on this particular particular flowchart data. So in that case, when it is giving you the mermaid or extraction of the nodes, means starting point, ending point, process start, so these one by one step of this flowchart, so these are actually represented by a node. So this may be hallucinated by VLM. VLM can't be able to provide you the more information. So now what we need to do, we need to retrain the model, or fine tuning the model using some data. So which is basically cost, costly, because it's require a large computations, is required a large system to train train a VLM model. So for the same, for the vision, if you see different ELO object detection model, so these models are trained on some data, like if you consider the Coco data set, they are benchmarking on this. So Coco has some 80 different classes. So what if you want to develop a model for a domain specific, like industrial specific problem, so in that case you have to gather the data from the industry, you have to annotate the data, and after this we have to retrain the model using this data. So in that case, retraining and all these things is necessary. But here in this agentic AI system, the system tries to learn from the data or from the context whatever you are providing to the system. So this is one advantage where agentic AI comes into play. So and finally, it uses decision making algorithm to ensure the best possible outcome. So now, if we look into the depth, how LLM era shifted to agents. So standard LLMs are reactive, so they don't have memory or a sense of state. But agentic AI uses the agentic loop: observe, plan, act, reflect, and then learn. Then try to learn. So if you see, LLMs are reactive only if you provide the input based on the context. It will provide you the output what the model has. But what if, in case of agentic AI, it tries to observe tries to observe the pattern of the input what you are providing to the system, and try to find out a plan of actions. It will act like that only. That means domain specific, and it will reflect and try to learn all the all the possible way to give you the best answer. It also relies on the modular integration of perception, memory, and reasoning. So what is that particular modular integration? So it has, memory, what LLM model doesn't have. So in that case, the system is persistent as a behavior. So this basically makes it stateful. So it is basically stateful reasoning, maintains context across the task to adapt and improve over the time. So now building and deploying an agentic AI. So the first LLM model is design, build, and test, which involves designing, building, and testing the LLM models that will power the AI agent. And then the next step is we extract, transform, and load, which involves preparing and loading the necessary data for AI agents. Then vector store index. So here creates and maintains vector index for efficient information retrieval. So vector storage index basically used as a storage memory where we store all the data in form of vector, and we try to retrieve all the information. So now API development. So for every specific small task, we have to use the API calls. So this basically builds the necessary APIs for the AI agent to interact with the other system. The next part is OCR. So implements OCR capabilities for processing document images. So what exactly the OCR do? So as I just before explained about the flowchart. So when we are trying to each and every flowchart have some rectangular shape, or some pentagon shape, or some circular shape in the images, but inside this it has legend means labels like start the process, input, like this. So these text basically are retrieved by OCR, so which basically give you the extracted information by going depth into this particular image and try to find out this text and give you a list of text. So later part it is doing the text embedding and prompt engineering, it comes into the later part. But the system first, these are the initial steps what we follow to building for to build and deploy the agentic AI. So LLM API, what it does, the final step involves deploying the LLM API. So this API may be involved not only LLM, it may be VLM. So API call using OpenAI API call. It may be Anthropic like Claude API call we can do. We can call the API from the different model Quan or Lava or Mistral. So all this through the Hugging Face. So from the Hugging Face also we can call the API and we can use that particular models. So these basically follows the path of the LLM extractions, LLM model used for extraction, and then makes the system as a autonomy system. So here we see full architecture. So first, the system can perceive inputs via text, audio, camera, or sensors. It processes all this through multimodal fusions. So multimodal fusions means all the information, different domain informations. So like camera information, images are coming, text are coming, audio speech signals are coming, and maybe sometimes we may use the sensor data. So these information are coming together. So these multimodal fusions are processed first, and then comes the cognition, which basically refers the memory and knowledge. So this basically knowledge base, and this cognition helps to do the decision making and try to store each and every data point informations in the memory and try to improve the results based on the previous stored results. So finally, it execute task, whether physical actions or digital ones, with the feedback loop for monitoring and learning. So finally, it monitors and learns from the real world data what you are providing to the system. So the real use case are many. Out of them, some are listed below, where agentic AI system are using to perform the task in various industrial sectors. Like nowadays, we have lots of agentic system. Out of this, some of them are life insurance policy recommender, so which basically suggest appropriate life insurance policies based on the individual circumstances. So like when you put the details about your name, your age, and other informations like some assured, or maybe there are some more information. So based on this, the system automatically calculate and provide you the suggestion which policy is suitable for you. So so nowadays in every company, HR support agents are there, which basically assist with human resource tasks and employee inquiries. So this is actually automatic system. When we put some query to the HR system, that agent basically help us to give the proper information. and all the information basically stored in a database where the model is trying to see the pattern of the information given by the users and try to improve the decision of the agentic system and try to provide you the best answer. And for the IT support, provides technical support and resolve IT issues. And there are some applications like financial decision making agent. So agentic AI empowers finance with smarter decisions, risk management solutions. So for the finance system, there are many applications nowadays which adapt the agentic system into their environment, so that user can go there and ask for their ask for their financial decision making, and tries to provide you the best best uh, best information on which where you have to invest or something like this. So it may be in stock market, it may be in your any of the banking system, it may be mutual funds. All things are there. So IT issues resolver agent, as I said, diagnosis, resolve IT problems. And the most important part, nowadays the agentic systems are used in healthcare systems also. So managers referral for the home health services. Email, obviously we all have seen that handles customer inquiries via email also. So home care marketing, all these are nowadays the applications of agentic AI. So, as promising as agentic AI is, there are some serious challenges like ethical risk in the sense like bias or lack of transparency. Means if the system doesn't have the proper information from the data, uh, there may be ethical risk and it may bias your results. Uh, there is a security concern. So how do we protect data and prevent misuse? So sometimes when we provide the data about the customers, it may be crucial for us to check the security concern of this and try to prevent this technology to be developed, where we try to identify so that it can't be misused in everywhere. So there is a need for explainability, so users understand why AI acts a certain way. So finally, integration of AI system is existing infrastructure is most crucial part. So everywhere we talk about agentic AI, but most of the industrial sector doesn't have that existing infrastructure. So it's not like a agentic system doesn't require the system with a large amount of data or computation. So it actually requires a certain amount of data, or it requires a huge computations. But nowadays the cloud systems has provided that particular solution. So now this is also it's not like it's compared to the previous AI technology, it is cost effective. No, it's not like that. So it's actually costly. But how to maintain this integration of this AI system is the most crucial part, because building a API call, multiple fed to the model, and multiple model call through API. So these all are require actually the larger computations. But at the end of the day, when we about the agentic system, it basically provide you an autonomous process, where the model is automatically defining decision making capability, designing the prompts, how whatever prompt you are providing. Based on this, it is not static, it is improving. And self-learning capability, it has a self-learning capability from where it is trying to identify the most important context from out of this and provide you the best part. So the risk is there, and also there are some challenges. So we need to keep focus on these challenges. We need to talk about those risks, and we have to come out and we have to execute in a way so that risk can be eliminated in certain way, or up to certain percentage. But yes, we need to lead with those challenges. So the road ahead to the future. So tighter human human AI collaborations is the most important part. So it is required everywhere, but the human and AI collaboration is necessary, because when we provide the information to the agentic system, human acts a vital role over here, because until and unless you provide the more important context to the system will not be able to identify what exactly you want to come out from there. The model can get the information, model can learn the things, but sometimes as I mentioned, it may bias, it may hallucinate about the data, it may give you the wrong answer. But you, with the human intervention, sometimes it helps to learn the capability of this learning process. So smarter system that augment human intelligence. So it should be more robust decision making tool. So nowadays AI that adapt seamlessly to its surroundings. And enterprise wise, if you see the intelligent automation that transform how we work. So intelligent automation is the good thing, but everywhere we are using AI, agentic AI, but still the agentic AI is not much as intelligent how we actually predict. So human intervention is still required, though we are talk about that agentic AI is not required human intervention, less human intervention, all these things, but providing the information by a human keeps the model more learnable. So maybe on the domain specific also it requires to provide the information. So you only can provide the information, we only can provide the information to the model on the specific task or the specific domain, so that AI system can get more knowledge about those data and get the more context information out of this. So this is the last slide. So that's all for today from my end. To conclude, the agentic AI represents a paradigm shift. It's not about the smarter models actually. So it's all about system that can think, act, and improve with model, improved with minimal human oversight. So we are at the threshold of a new era of AI-driven autonomy, and obviously with the intervention of us we can improve more to the agentic AI system, so that it can get more static decision making system. And sometimes we talk about the domain specific. Yes, it is domain specific, but we can provide the more information to the AI agents, so that model can learn more information, more data information out of this. So thank you all for your time. So I welcome for any discussion on this topic.
Yeah, thank you, Dr. Soumen. In case anyone has any questions, feel free to ask.
So in the meantime, I'll probably ask questions while the others try to come up with some. So Dr. Biswas, thank you for an excellent presentation. So I was wondering if you can tell us about the scalability of multi-agent agentic systems for large-scale operations. How scalable is the technology right now?
So yes, that is rightly said. So as we know, the scalability, especially if we look into the autonomous or semi-autonomous one, so it can expand in complexity, capability, and coordination as per the task what we do. And with the context of the task complexity also it dependent. So how the complexity of the task, how the task is complex. Based on this also we can scalable. But the most important and challenges part would be the API call and the uses of and the use of resources. So resources means like I am saying about the computational resources. So maybe one single system cannot be used for a multiple APIs. So in that case, scalability of agentic AI is much more challenging. But yes, if we consider the multi-agent collaboration, so in that case, it requires more communication, coordination, and all these things. Because agent struggle to sequence tools reliability to get more complex data. And also, if you look into the hallucination under the autonomy, agents invent facts where unsupervised or unspecified data is there. So yes, scalability is still challenges today because the model are not optimized yet. Because if you see LLM itself is a huge to call because it is trained on the 70 billion, 20 billion data, 7 billion data. So for a single without a GPU machine, so minimum if you say 48 GB GPU, so minimum 48 GB GPU only can handle 7 billion data. But what about if you want to use the inter LM, so which is basically 20 billion data. So for this you require more larger computations. So in that case, the scalability use of agentic AI is still challenges. But yes, probably the researchers are coming up with multiple optimized, fine-tuned model where more number of data is included. Also, quantized version of LLM models are already in the market. In the Hugging Face model, Hugging Face also there are many quantized models are there. So yes, to be specific to your question, scalability is still challenging. Is that answer your question?
Yes, thank you for that.
Thank you.
So while others are thinking, I'll probably ask another question. So that brings up to the answer. The answer to the previous question brings up another question, leads to another question. Are there any specific examples of large-scale agentic AI that have been successfully implemented in real-world applications?
So yes, there are many here are many real-time applications are already there. So as I mentioned, there are one software that is Devin. Devin is AI software engineer that is designed by Cognition Lab, I think. So they basically use the agentic AI. So this software is basically for writing the code, debug the code, and automatically, correct the code. So, and also if you see the OpenAI API based, so ChatGPT. So that is also nowadays, as I mentioned, nowadays it is agentic AI system. So it is successfully implemented. So just to give you a precise context on this, so I think you have heard about the Olama. So Olama is a LLM model. So if you ask a current questions, if you ask a current question to the Olama, like recent question, maybe last 1 month, maybe last 2 months, or maybe 1 or 2 days, a hot topic of news anywhere in the world, Olama won't be able to give you the proper answer. It will say you that that particular context is not to this particular means he is not trained on this, or he will not provide you the data exact answer. But what if you give the same question to ChatGPT, it will give you the answer, but provided if you see over there, they will do the web search. So web search agent is basically trying to put that particular context what you have asked to ChatGPT, it is trying to pull that information to the web, searching for the answers or searching for the information what you ask, and it will provide you the answer. So yes, today's world, if you see, so Devino and one OpenAI is the most recent example of using the agentic AI.
So Devin is an agentic AI system, is it? I thought it was just.
Yes. No, Devin. Also, Google DeepMind, that AlphaCode also agentic AI system.
And one other question I had was how can, there is a question from Sabarish. So Sabarish, please go ahead.
Hey, thanks. Yeah, I just wanted to ask, do you see the growth of MCP servers and converting all the REST API protocols now moving towards being more MCP compliant so that they can interact with LLMs and kind of bolster the whole agentic kind of experience? Just wanted to get your thoughts on that.
Yes. So now that yes, we are absolutely seeing early movement in that directions. But if you see the TL or DR, like MCP, so that is machine callable protocol. So this basically use the agents, different agents. So first it will REST, calling the REST API functions, and then trying to interpret with the agents, and it makes the model autonomous. So yes, nowadays it is the paradigm is shifted to the API calls through the MCP. But if you see the computation on the MCP also, it is not comparatively less compared to the REST API. So it is also require the computations more on this.
So I think Anuradha has her hand up. So Anuradha, if you can go ahead.
Hello. Yeah, first of all, Dr. Biswas, thank you very much for the great presentation. So my question is, how ready do you think are the different industries for this transition, that is transition to agentic AI? Do they have to take a leap in their level of implementation, hardware? Do they have to invest a lot to adopt agentic AI in their workflows?
Yes. Thank you so much for this question. Yes, the obviously, as I mentioned, the um, integration of this agentic AI system in the industry is the most important part. So nowadays industry is not yet ready, all the industry is not yet ready to cope up with this agentic AI system, because if you see over the last 2 years, the technology, if technology growth is in such a rapid direction, like it's starting from AI, it shifted to generative AI, and then coming the LLM in the market, and suddenly it is going to the agentic AI. So it will take more time, because industry need to invest a lot to build an infrastructure to cope up with the to build infrastructure, not only for the computational resources. They need different server systems to communicate different APIs. So APIs basically helps human to interpret. So yes, maybe over the time, it will take time, but maybe over the time, industry will cope up with the different investment purpose, or may can use maybe can use for the agentic AI system. So nowadays what you are seeing everywhere, it is small applications like that tool kind of thing, HR, automatic email reply, all these things. But if you go into depth for real world practical applications, like in healthcare, automatic give the automatic answer or suggestion on what exactly the patient is required. So nowadays everyone is doing that. If you get a prescription from a doctor, if you upload it into any of the agentic AI system, maybe chat GPT, then it will give you some certain dedicated answer, means some certain medications. But now whether this medication suggested by AI is reliable or not. Here it comes the reliability. So still this agentic AI system need more, more in-depth information in different domains, and probably in coming days we'll get into some solution.
So one question that is on the chat, I think it's a direct message to me.
Okay.
So is whether the speakers can provide the slides. So if the speakers provide the slides to us, the organizers, Rahul or me, we can upload it to our website. But otherwise, the audience can directly contact the speakers for the slides, because there's some intellectual property involved. We don't want to get in between. So probably there's time for one more question. Okay, let me ask one question. So from what I gather, agentic AI currently, I mean, a lot of people have this on their mind on how they can orient themselves to work in the agentic AI space. So from what I see right now, it is just like plug and play. I looked at some of the tools like N8N,
True.
Zapier. It's like plug and play, the just drag and drop kind of thing. So is there real skill set required um, for the technical folks to reorient to get into the agentic AI job market?
Yes, very true. It is required because as I mentioned, some of the API may be needed some domain specific task. So for that, it requires the expertise on this specific domain. Suppose if you want to implement a agentic AI system in semiconductor industry, so those who is working in other industry in software development part or other part of the industry, they might do not have much idea about the semiconductor, how the wafer actually looks, how the defect in the wafer. So a domain specific expert obviously needed for these applications. Yes, it will help the agents. As I mentioned, human intervention, less human intervention, but human intervention is required. So as human intervention is required, there should be expertise. There should be an expertise from each domain where we are trying to implement the agentic AI system.
So most of the skill is in the domain and not really in the agentic AI space, I think, right now?
Yes. In the domain specific knowledge.
Okay. Thank you. So Rahul, shall we move on to the next speaker?
Yes.
Yeah,
Thank you so much. Thank you everyone for your wonderful questions and thank you for your time.
thank you, Dr. Soumen, for giving a wonderful presentation. Okay, so next we have Kamar Ali, who is head of Agentic AI at AI Explain. So he will give a presentation on the rise of autonomous intelligence and how AI agents are redefining science, art, and business. Yeah, so Kamar Ali, please go ahead.
Hello, everyone. Thank you for attending to this presentation. My name is Kamar. I'm based in Germany, and I'm currently working as the head of Agentic AI and distinguished scientist at Explain. Explain is an AI agentification framework from Silicon Valley, and we are recognized among one of the top 10 agent frameworks by CV Insights. So for people who might not be super familiar with agents, in my opinion, they are simply static or dynamic workflows of LLM calls, which may have like different personas and the capability of tool usage. So basically, when ChatGPT is emerged, for example, somebody who is using LLMs for coding, they would manually execute those workflows. For example, we would copy and paste our code and then ask for a refinement or for debugging, and then we would execute the code ourselves and then paste back the error so that the LLMs refines those. So people have quickly noticed that if we can execute those workflows autonomously, we can have much better results than just calling the LLM once. And on top of that, we can also have LLMs to, for example, self-reflect or plan to execute a chain of thought, for example. So what matters here is that basically having multiple calls to LLMs in a workflow boosts the quality of the output. And the models like O3 or O4 that you see nowadays at ChatGPT, they are also agentic, so they are not working as single LLM calls. So at Explain, I'm currently working on two major topics. One is autonomous optimization of agentic AI solutions using LLM-driven refinement and feedback. We call that Evolver. The second is autonomous meta framework for enterprise multi-agent use case generation and implementation and testing fully autonomously. And apart from that, I was previously heading our solutions departments. So I want to talk about a couple of agentic AI use cases that we have realized for enterprises. For example, we have done solutions for automatically compiling market research reports, investment decks, doing competitor or SWOT analysis of companies, or different co-pilot applications. For example, one for technical project manager, which helps technical project manager to run the project from the proposal creation to project execution, including budgeting, resource allocation, the timeline or task planning, etc. Or Agent AI solutions for HR departments, which conducts automated video interviews, evaluates candidates, and makes a selection of the candidates by providing a rationale. And of course, we have also made a lot of RAG-based applications or text-to-SQL agents in order to make sense of structured or unstructured data to answer questions business may have on their knowledge bases. So today I'm gonna focus mainly on the evolutionary or artificial curiosity-driven use of large language models or agentic systems in different applications in art, in business, as well as in science. So first of all, I will talk about some of the recent breakthroughs in autonomous scientific or algorithmic discovery. And then I will talk about why LLMs are great to act as an evolutionary operator to drive those innovations. And then I will talk about, shortly talk about the artistic, which is basically a creativity related piece of that. And also some of the research I have published on making scientific discoveries in quantitative finance domain. And then I will revisit my work at Explain, where I have done work around autonomous agentic AI workflow optimization, as well as another, our patent pending technology, which is about autonomous generation of business insights from structured data using artificial curiosity. So can AI make scientific discoveries? This is a big question, but we have seen in the past years a lot of publications which have been able to discover new scientific methods in different domains. So some of the notable examples are listed here. For example, AlphaTensor was able to discover better matrix multiplication algorithms than previously human-made. AlphaCode invents faster sorting algorithms than humans. AlphaEvo, which is a recently published paper, didn't just invent a state-of-art matrix multiplication algorithm, but also it's more in general domain, and Google also use it to optimize their scheduling heuristics or invent better hardware circuits, etc. And Google also had another paper which is called AI Co-Scientist, which helped scientists from biomedical domain to make some scientific discoveries. And there is AI scientist from Sakana AI out of Japan, which automates the research process end to end from basically idea generation to implementation to experimentation, as well as writing the paper. And they have another work which is called CUDA Engineer, which takes an existing deep learning model and invents CUDA kernels which would optimize that. So if you look at how co-scientist works, for example, shortly, basically co-scientist is a multi-agent system which takes a research goal, and then using its multi-agents, it basically makes a simulated scientific debate process. And while doing that, it also uses different tools for example, searching online and like finding, for example, relevant papers or reports to do literature exploration to help it to develop better hypotheses or better ideas, or find, for example, theses which are supporting or which are antitheses for a certain hypothesis. So it uses all of these agentic process to basically develop like new hypotheses or new experimental protocols in order to invent like new methods in biomedicine domain. And it also uses like self-reflection processes to like refine the ideas and like keep the hypothesis generation or keep the idea refining during this process. And Sakana AI scientists, as I previously mentioned, it automates not just the creation of scientific methods, but the whole process from primarily in computer science domain to have a research to find different ideas that targets a research goal, and then check the novelty of those ideas, scoring those different ideas, and then or refining those ideas and implementing those individually, and finally creating also the experimentation codes to experiment with those different implementations, and finally writing and refining the publication or manuscript fully automated in a fully automated process by agents. So this is actually not completely new. So we were actually like the researchers were actually already using grammatical evolution or symbolic regression in order to discover different formulas or algorithms. And already like several state-of-art activation functions, optimizers, or architectures in deep learning, they have been discovered through these methods. And an advantage of this over different methods of meta learning is that at the end you get something interpretable. So you get an evolved code piece, which enables human AI collaboration. So basically, what you get at the end is not a black box policy, but it's an actual algorithm that a human can understand and also make improvements upon, or provide feedback to drive this evolutionary process to better directions. And LLMs, so LLMs or agents made this automatic algorithm discovery process even much more efficient, and I will basically explain you why in the next slide. So how we make scientific discoveries as humans. So first of all, we take inspiration from a literature or identify a method that we want to improve upon. and then we identify the state-of-art methodologies on that domain, and later we generate ideas or hypotheses on how we can improve the
I think we lost the speaker.
Hey, I can't hear him. Let me try to reach out to him. Yeah, so he has some connection issues, so he is joining again shortly.
I think we can wait for a couple more minutes. And if we still don't have him, then probably the next speaker, I think Dr. Anuradha, right? If Dr. Anuradha can start her presentation, if she is ready.
Okay.
In 2 minutes. We'll give it 2 more minutes.
Hello.
Okay, he's here back.
Hello, yeah, we can
Yes.
hear you. Yeah.
Sorry, my connection had a problem. So let me share my screen. Okay. So I was explaining why LLMs are basically boosting the science, are capable of boosting the scientific discovery process. So, like while making scientific discoveries as well, we have different steps. So we inspire from the literature, we identify a certain state-of-art methodology which we believe we can improve upon, and then we generate ideas. We maybe like look at papers to like develop some ideas or borrow ideas from other domains, and then we implement modifications on the state-of-art methodology based on our hypothesis, and we evaluate our methods, and finally we report outcomes, whether it's a new state-of-art or not. And if it's not a new state-of-art, we go back and we do this process again. And large language models are great to automate this because, first of all, they have cross-domain knowledge, and they are able to understand both language and code, so they can basically understand papers of state-of-art methods or their implementations. And they have critical thinking or reasoning capabilities. They have code implementation capabilities, which means that they can apply those modifications themselves. And they have the tool usage to run the experiments, and they are also able to interpret the experimental results, like making plots, etc. And finally, they have language generation capabilities to like write the publication itself based on the obtained results. And this whole process can be done through an evolutionary process by leveraging LLMs. So we can, for example, provide LLM like examples of an algorithm, and we can ask LLM to cross over different variants of an algorithm to combine their strengths, and we can ask an LLM to generate ideas or hypotheses on how to improve a given algorithm, and apply those hypotheses as mutations to generate a new set of variants of that algorithm, and then they can also do the tool usage to execute and score the outputs. And finally, they can also act as a selection operator by quantitatively or qualitatively judging the output of a certain method. So we can, which means that we can implement all of these as an evolutionary agentic process, which generates variants of like mutated variants of an algorithm, and then ranks them, pick the best ranked ones as fifth-shot examples to crossover and next generation. So this can be an iterative loop. So now I'm gonna show you some like visual examples on how that's applied. So for example, in this example, I use this process in order to generate shader animation codes, like GPU shader codes, through an interactive selection process. So below, as you can see, those are all mutated variants of different the same code piece. And we can have a human, for example, select the best variants here by watching those the animations, like procedural animations generated. And based on those parents, we can breed a new set of variants. And at the end, we can have a much better shader animations, which is reflecting to what we desire as human experts. So when we also talk about mutations, one good thing about LLMs, they are able to do not just random mutations for exploration, but they are able to leverage their implicit domain knowledge to apply directed mutations, like mutations that are expected to lead an improvement. So this is another application I also made. These applications, I was evolving basically computer-generated art by optimizing prompts for generation. So for given art piece, LLM, actually in this application, I used a visual LLM, and given an art, already generated art, it's able to like write a prompt for that art piece, and then it is able to use as a visual critic in order to like review the generations and reflect how they can be further improved upon. So in order to generate hypotheses for improvement, and after those variants are created, it is able to like redo those visual critics in order to optimize the prompt. They are prompt which is used to generate each. And while doing that, we can also have the LLM to act as an expert in a certain domain. So here, the LLM can be an expert in visual art, so that it makes so that it can have a chain of thought process in order to make good mutations which would lead to better artistic results. And this is another application I did using the same methods on architecture domain. So here on the top side, I'm optimizing prompts for internal architecture, and on the downside, I'm optimizing prompts for exterior architecture of a building. And this is that was all about the creative piece, and this is another similar application I did for optimizing landing page. So if you are familiar with like digital marketing funnels, etc., you may know that like optimizing landing page is an important piece of the growth hacking process. So generally, people are manually creating variants of landing page in order to test which one is converting better, and they keep on optimizing those. So here I use the same evolutionary process to automatically generate better variants of a given landing page, and then keep evolving them based on incoming traffic. And the system as well is able to criticize each landing page based on the looks, so by using a visual LLM, and also incorporate that into the evolution process. And this evolution process works autonomously, but it can be also a human in the loop process as well. So a human expert can also incorporate their thoughts into how that process is applied. And now I'm gonna talk about some quantitative finance applications I did to discover like different metrics or algorithms or methods in quantitative finance domain. So like some of those papers are published in ICLR and ECML conferences as part of the financial AI related workshops. And they are recently the top papers in SSRN under several categories. So the first paper I'm going to talk about is about inventing new risk-adjusted metrics to be used in quantitative finance. And the second and third is about inventing either portfolio allocation heuristics or the objective functions or loss functions in order to optimize portfolios. And the fourth paper is related with basically having an evolutionary process in order to like invent new predictive features for quantitative finance applications. So it's actually an AutoML themed paper. So I mean, if you are not familiar with quantitative finance domain, Sharpe ratio is, for example, the most popular metric which is used in that domain in order to judge performances of assets or investment strategies, etc. And it's the key metric in order to evaluate or optimize portfolios or select assets. But the problem with Sharpe ratio is that actually the past history of the Sharpe ratio, so past Sharpe ratio, doesn't really correlate very well with the future. So it actually doesn't make sense to make predictions based on that. So the correlation of past Sharpe ratios and future ones in financial market, for example, is just around 0.1. And here I used this evolutionary process I have described in order to invent a better Sharpe ratio, which correlates 3 times better than the Sharpe ratio, which is used in industry today. So it has like 0.4 Pearson or Spearman correlation, which is like significantly better than the Sharpe ratio itself. So in order to do that, I basically instructed agents to evolve, like run this evolutionary process while generating the codes with PyTorch, so that I can make batch computation across a large asset universe, which was consisting of almost 4,000 different assets. So here, the metric, in order to evolve it for robustness, so it shouldn't overfit to a specific asset, and that's why it's tested over 4,000 different assets during the process of evolution, in order to make the metric as generalizable as possible to different assets. And after applying mutations on a given metric and creating like 10 or 20 variants at an iteration, it makes cross-asset and cross-time validation to score them and rank the top performing metrics, both by quality and diversity of them. And then at each iteration, those ranked metrics are used as feature examples to crossover and generate the next parent for breeding. And here are the example prompts I used for this application. So there's a prompt for the crossover task, which basically says like your goal is to invent better investment performance metric by proposing new metric variants, and you should consider following examples to combine their strengths to come up with a better and no risk adjusted metrics. And you should do critical thinking, etc. And there's a hypothesis task, which basically generates hypothesis for improvements for a given parent. And there's a mutation task, which makes multiple mutations from the parent, which came through the crossover task. And the mutation is conditioned on the hypotheses which are generated, which means that like mutations are not just random, but they are actually follow the hypothesis for improvements. And here we can also see about the thinking process of LLMs, like while improving a metric. So here basically we see a thinking block about which is analyzing the metric and understanding like its components. And here we see its proposal for enhancement. So which is inspiring from different domains, from signal processing to financial theory to machine learning. So these are basically the generated hypothesis for improvement on which mutations will be made upon. And on the right side, we see the most robust metric which has been obtained through this evolutionary process. And at the down, we see the experimental results, which shows that it is like it has much better correlation, like Spearman candle correlation and non-discounted cumulative gain when compared with the original Sharpe ratio on the future performance of assets. So why this is very useful? Basically, we have now like much more significant predictor for selecting or pre-filtering assets, or to be used as a portfolio optimization target, or to evaluate investment performance or strategy backtests. So alpha portfolio is basically the same method applied to the discovery of allocation heuristics, and at the right side we see again the algorithm which is discovered, and And we also, on the left side, we see the experimental results, which shows it is performing significantly better when compared with the uniformly weighted portfolio, which is a very high benchmark for an out of sample period. So finally, final one is AlphaQuant. Basically, it's an AutoML system where the features are iteratively discovered. And on the right side, we see some examples of features which have been discovered through the iterative process. So at each iteration, it discovers new features, given best performing features as examples. And later it runs an AutoML process by excluding the existing or cached feature set with the new discovered features to see if there's an improvement. And after each iteration, it ranks the features again by the feature importances to keep on going this process to discover new features. So I'm not gonna go into like very much details, but here as well, like we have the prompts for the feature discovery, and I already explained you about the loop I have used here. And this is the experimental results. The color here shows the iteration on which the feature is discovered, and the height of the bars shows the importance of the feature. So what we see here is that we see lots of dark colors on the left side, which means that the system keeps on discovering better and more sophisticated features over iterations. And we see that on these plots as well. So the validation error has a downtrend over multiple iterations, and we also see that the correlations of the obtained model with the new features keep on increasing. So here I had a low hypertuning budget. That's why we see a decrease here once the feature pool gets too big for the AutoML model to handle. And finally, I also applied the same method to trading strategy discovery. And on the right side, we see the algorithm which is discovered, which is quite sophisticated. And at the bottom, we see the difference in performance in comparison to buy and hold of the Australian dollar and New Zealand dollar currency pair. So it was able to discover a viable strategy on Forex trading. So that was all on quantitative finance. So now I want to talk about my main research topic on Explain, which is using the same methodology to evolve agentic systems or agentic workflows. So as I said previously, I was heading our AI solutions department. And what I experienced there is that for the deployment of agentic AI applications, the initial implementation of an AI application is actually quite straightforward, and it takes quite short time compared to optimization of it. Because an agentic AI system consists of many agents with different tasks or different roles, etc., and a workflow between them, and even a slight change in, for example, on the role of an agent may have a negative effect on the performance of the agent. So the optimization or the hypertuning of agent AI systems are very difficult. They take much longer time than implementing the actual system, especially due to the stochastic process of prompt optimization or workflow optimization, as well as so it takes much longer than implementing actual system itself, as well as due to lack of automated tools for that. So that's why we have developed Evolver at Explain. So Evolver is a method or tool which autonomously optimizes those agentic AI configurations and workflow, given a quantitative or qualitative evaluation criteria. And the whole process is empowered by large language models. As in the other applications I mentioned, they are used for hypothesis generation, evaluation, and that enables the iterative refinement without human input. And our framework distinguishes itself by this open-ended evolution of actual enterprise agents using LLM as a judge, as a critic. And even on the absence of a qualitative evaluation criteria, Evolver itself can generate the criteria for a given agent system, and it can co-evolve the evaluation criteria during the evaluation process. So the system is composed of 4 main agents. One is evaluation agent, which runs variance, captures performances, compares and ranks them. The second is refinement agent, which detects performance gaps based on the output based on the given criteria. The third is hypothesis generation agent, which proposes new tasks, roles, refinements, or workflow modifications based on analysis of outputs based on the criteria. And the fourth one is the modification agent, which applies those hypotheses to produce new systems variants to be executed. And I can talk about a couple of examples where this has been applied. So, for example, we had a career transition helper agent, which aimed to help software engineers to transition into AI roles. But the outputs fell short on domain depth, goal specificity, action plan structure, etc., or communication clarity. So after applying Evolver, it added new agents with AI expertise and skill development. And it also added an agent for industry trend analysis. And also it reframed existing tasks to generate smart objectives with detailed timelines or concise explanations. So the evolved system was able to deliver much more clear industry-aligned goals or actionable plans for career transition, which obtained much higher evaluation scores and drove much greater user engagement or completion rates. So the second one was a lead generation agent, which was generating leads for an AI personalized learning application. And the outputs were underperforming on strategic alignment or lead qualification depth or data completeness and the originality of insights. So the Evolver added specialized data, market, and business development analysts. It restructured tasks for more granular lead validation and industry trend analysis, and refined the actionable and strategic insights produced by the system. Which led to a significant improvement. So another one was a marketing post or blog post generation agent, which produced posts which lacked depth, or audience engagement, or visual storytelling, etc., as well as credible sourcing within those spots. So Evolver added specialized researchers, engagement experts. It broadened tasks to include literature reviews or visuals, interactive elements, and so on. And the system produced much more nuanced, accurate posts with stronger engagement potential, with compelling visuals, clear citations, and effective calls to action, which at the end boosted the audience interaction. So I'm in the list. I have 2 more examples, but if you like, I can skip them. So I believe you got the idea. So Evolver, using the same evolutionary method, which I described, which is very useful in inventing new scientific methods, for example. It's able to optimize the agentic new workflows by adding tasks, agents, changing their parameters, etc., to optimize them for a given qualitative or quantitative criteria. And here we see the experimental results, which shows the mean scores across different criteria dimensions. And we see that for each agent, each basic agent we have provided to Evolver, it was able to significantly boost those scores. Yeah, that's basically about Evolver. So empirical case studies demonstrate significant performance gains. The targeted specialization and workflow structuring lead to substantial gains in agentic systems, and introducing special agents or tasks and criteria-centric designs enhance the outputs dramatically. And it is able to continuously improve systems through the iterative evolution process. So now I'm gonna switch over to a different application on the remaining time, which is actually one of our patent pending technologies. So this application is a business intelligence system. Sorry. This application is about autonomously. It's about not just optimizing given agentic systems, but autonomously implementing agentic systems starting from generating the ideas. So this is a good example of artificial curiosity, in my opinion. So here we have an innovation agent, ranking agent, and execution and scoring agent. So driven by LLM on the online knowledge and the tool inventory, for example, the RAG system, the system tries to generate a feasible set of ideas or impactful ideas for a given market, ideas for agentic AI systems. And then it evaluates each of the idea generated, basically acting as a venture capitalist or an investor. And it then refines or selects from the generated ideas to implement those as multi-agent workflows. And later it runs the generated agentic systems on a simulated test environment. And finally, there is a final scoring agent which judges the outputs of the generated ideas. So this is basically an application we work on to mass implement or mass generate agentic systems which may be helpful for different enterprise use cases or automating different processes for a given enterprise. And the final application of artificial curiosity I want to talk about is on business insight domain. So text to SQL tools are quite popular nowadays, and they generally work in order to answer a given question from a business expert. So they are very capable on when a question is given, they are very capable of generating the SQL query to extract the answer for that question and to visualize or interpret the outcome. But this is a reactive process, so you trigger this process. And at Explain, for a project, we created something very new, like something very different, which is proactive. So instead of a human expert asking questions, the system generates which questions might be relevant or might be worth to seek for answers, given a structural database of a business. So it basically acts as different departments, different executives within the company, and it generates questions which may be relevant to those executives. And this way, basically, it uses an LLM-driven curiosity to seek answers for thousands of questions which may be answered with a given database. And after it extracts the answers of those questions, it turns them to actionable insights or recommendations for the company or for different departments of the company to compile a report. So these are some examples of insights extracted autonomously. So you can assume that like thousands of such insights are extracted. So the system acts as a consultancy team, which is expert on SQL, data visualization, or business expertise to extract mass insights from your business. So it takes like snapshots of thousands of different situations to come up with a strategy for you at the end. And we also see here an example insights. Again, like I'm not gonna go into further details. I will share this presentation with you. You can like check this example of the generated insights yourself. That was all. So the key takeaway of my presentation is that LLMs or agents, they are not merely tools which realize what we tell to them, but they are able to act autonomously as ideators or scientists or artists in order to basically make human level discoveries in science or art or business. So generally we have a egocentric view of how we observe the technology. So we feel that we are in the control and we tell them what they are doing and they are very capable of in what they do. But I think we should see that in from a different perspective as well, where they are the ones who are generating ideas for us as well, or basically collaborate with us to generate those ideas, not just to apply, but also contribute on the creativity or idea discovery process. So that was all. Again, thank you for listening. I can take your questions or feedback now.
Thank you, Dr. Kamar. I think Ranjita has her hand up, so we'll ask. So please go ahead, Ranjita.
Thank you. And this was amazing, a very insightful talk. Thank you, Dr. Ali. I have a lot of questions, but I'll stick to a couple of them. So one is for the LLM-based scientific discovery process. You had a kind of a flow chart, if you will, of the workflow. How much of the workflow is actually static versus like dynamically generated by one of these agents?
So my implementations are generally quite static. So I don't believe that you need like a dynamic process often. And a dynamic process, although it sounds good, it makes some applications less robust. And when you have a well-defined process, I believe the best way to go is static. In Explain, we have our own agentic system, which is called Mentalist, which actually generates the workflow on the fly. But since that the workflow is pretty much defined, like my own preference is to go with a static process.
Makes sense. But for Evolver per se, you kind of have a little bit more freedom in the workflow definition, right?
So I mean, although when you define a static process, it basically includes some like dynamic routes. For example, when you create, let's say, multiple variants, and let's say some of them, like all of them fails in improving the system, then maybe you go back and like seek for more ideas. Or so basically, it's like even though it's like a static automata, it still includes some routes, like some directed cyclic graph cyclic graph to navigate.
I see.
But the agentic systems evolved by Evolver can be both static or dynamic, and actually, especially you need Evolver for dynamic agents, and the reason is follows. For dynamic agents, we generally try to effect the prompt is more important. So if you have a managerial agent, for example, or if you have a single task description or agent description from which the prompt will be generated. The task plan will be generated. The prompt used for that is quite important because it will make or break your agent during the planning. So if you have like more refined or constrained prompt, it may lead to a better plan when that dynamic planning happens. So that's why Evolve is quite effective in optimizing such cases. And that also Evolve also doesn't just optimize the prompts or roles or tasks, but it also optimizes the workflow. Or for example, some agentic frameworks, they have like delegations in between agents. And some agents can delegate, some others not. Some is a manager agent. So all of these hyperparameters are crucial to set correctly. And that's why an automated process helps that a lot. As I initially said, for example, if implementing an agentic system takes, I mean, nowadays it takes maybe a couple of days, like at most a week, but optimizing that for enterprise level robustness takes maybe multiple months without an automatic process which takes care of the evaluation, like setting the parameters or prompt optimization or engineering.
Oh, I agree. Thank you.
You're welcome.
So once again, thanks a lot for the excellent presentation, Dr. Kamar. Of course, I also have a lot of questions, but just quickly, so Elon Musk was saying just a few days back that Grok, the latest version of Grok, is equivalent to several PhDs. But only thing he said is that research is just a year or two away. So from your presentation, looks like we are already there, right?
I think so. I mean, the big question is, I believe, are those systems interpolate or extrapolate? So these questions comes often to me when I'm presenting this in conferences. So which means that are they really discovering something very brand new, like something like a super breakthrough, or are they just like assembling pieces from like multiple domains and so on? And my answer to that is basically, I believe, like us as researchers, we are also doing not large breakthroughs like most of the time, but iterative, like incremental progress in science. And what we do is also generally not extrapolation, not contributing something like super new to the world's knowledge, but often like borrowing some progress from like other domains or making like iterative modifications based on our like hypothesis to improve a scientific method. So what I'm trying to explain is that I don't believe we are doing something very differently 99% of the time when we are doing scientific progress. So in that respect, I think we are quite equivalent. But large language models have a large advantage. They maybe have a less knowledge, let's say in computer science, than myself, but they are expert in every domain. So they may be like PhD level, but they are PhD level in many domains, like hundreds of domains, which none of us can be. And they are also able to, so they are also able to work, let's say, asynchronously or in a scalable manner. So it takes us time to, for example, try different ideas. So we are limited in like number of ideas we can try. But large language models, on the other hand, or agents, they are not constrained in that given the computational requirements. So they may be, instead of us trying 5 viable ideas, they may try thousands of ideas, but maybe only like a few of them or 100 of them may be viable. So since that their speed of execution is like much more scalable than humans. They are closer than us to like find breakthroughs, and which they did as in the examples I given, like with AlphaCode example or Alpha Tensor example, and with others. So they are already able to make contributions like so for example, Sakana AI was able to actually publish a fully autonomously paper in ICLR conference on a workshop. So they are so from end to end, like from the idea to writing the paper or visualization, etc. Like all was done fully autonomously, and the paper got published in a top AI conference. So they are already doing progress, in my opinion.
So you think they're already extrapolating to some extent?
So, no. So what I mean, what I meant, like they don't need to necessarily extrapolate to do a PhD level research. So that would be, I mean, they might be extrapolating as well. I don't think that happens yet in a very like significant way that it changes our society or it changes like the science like completely. But for a PhD level scientific contribution, I think they are already making. And when we think that they make this on mass level or they collaborate with us in doing this to scale ourselves, the current scientific progress can be significantly accelerated. So that's my opinion. And I'm already using such agents in my research as well for like many parts, for literature review, for giving me ideas, for implementing those ideas. So I'm already benefiting from that, and I believe like many PhD students or many researchers are already benefiting from that in certain parts. And the question is whether we turn this to a framework to fully automate this or fully like exploit or leverage the contribution of this.
Yeah, thank you. And I was also curious about the underlying technology. So does it use a lot of reinforcement learning, or what kind of thinking process?
Just large language models without model training, like pre-trained large language models.
So they are able to connect dots and then come up with ideas then?
Yes, exactly. But for example, I think that we can also use a similar process to generate synthetic data. So the way to, so as most of us know, large language models, they're already pretty much using all of the data available in the world, right? I mean, at least text data. So we can also use similar processes to generate synthetic data to add to the training sets of large language models, and I think that's what's gonna make them really improve. So if they are able to contribute back, through agentic processes to expand the available, like knowledge base for their training, for their own training. So if they can extend their training data themselves in a valid way, in a contributing way through synthetic data or pseudo data. Yes, Ranjita, I guess she has another question.
Yeah, so along the same lines as what Professor was asking, how actually do these individual agents communicate? Like, what is the protocol, if you will, between multiple agents? So I saw a lot of your workflows ended up having one agent interacting with another. So how much of like customization do you have to do for each of these interactions? Or is there like a framework that you follow, protocol that you follow that can be used in multi-agent interactions elsewhere as well?
Yeah, I mean, customization currently happens on not on the workflow, but on the prompts, depending on the domain. Like, for example, if it's quantitative finance, then the prompts are different than others. For Evolver is a generic system, so it can be applied to any set of agentic system, especially since that it's capable of generating the qualitative criteria to judge the system itself. So it's able to do the customization of the qualitative criteria itself without human input. So that's generic. But for the other scientific discovery work, I'm generally just or artistic work, I'm generally just tuning the prompts, not the workflow, and the evaluation method. So if it's let's say should be evaluated, so the evaluation, like quantitative evaluation method, should be implemented and plugged. Ellen?
Yeah, so the analogy of hallucination in these agentic systems is that they'll sometimes do something unexpected off the track from the plan. Do you see that? And if so, how do you control it?
So in the applications that I have described, it can actually also be regarded as a strength for like creativity. Let's say, so to not overfit to like certain solutions, to be able to explore. In more enterprise applications, hallucinations are, of course, I mean, I actually agree with the previous presenter. Basically, the biggest bottleneck for enterprise application is generally the robustness of the systems. And that's why also we need to like optimize them, like not just develop, but optimize them so that they are less prone to hallucination and so on. So the answer is yes, they are prone to hallucination. Having the right flow, workflow, prompts, validation processes or guardrails helps avoiding that or overcoming that. But the systems are also improving too fast, like much faster than we follow. So I don't see that as a bottleneck in the long term. So I think just the technology is developing. Does it answer your question?
Sort of.
All right.
I think I'm pretty sure a lot of questions will be there. We'll probably call back Dr. Kamar again to our chapter for more insightful discussions. But I think it is time for us to move on to the next speaker. So thanks a lot, Dr. Kamar, and hopefully we'll be in touch. And
thank you very much. It was my pleasure. Thanks all.
yeah, so the next speaker is Dr. Anuradha. She is joining us from France. You would have noticed that the speakers are all from different continents, countries. The first speaker was from India. The second speaker, Dr. Kamar, is from joining from Germany, and the current speaker, Dr. Anuradha, is joining from France. So that is the whole purpose of this ICADS. We want to evolve it into an international conference with contributed papers and things like that. Once we have sufficient infrastructure, we'll get into that. But in the meantime, we are trying to involve as many countries and as many researchers as possible. So over to you, Dr. Anuradha.
Hello. Thank you so much. First of all, just want to check if you can see my screen properly, full screen. Okay, perfect. Okay, so hello everyone. First of all, thank you for the opportunity to speak at this conference, and I'm really happy that this is the need for the hour. One second. Yeah. So this is a need for the hour that we start talking about what is happening in the world of agentic AI. So I propose this topic that is from algorithms to agents, the role of agentic AI in healthcare. I will So, 1 second. Yeah. So this is the outline for my presentation today. So I will be starting with where do we have AI algorithms in healthcare so far? What were the major innovations done in the field of AI for healthcare in the past few years? And why at this point of time we are thinking, or the healthcare domain researchers and I would say companies are thinking about moving from algorithms towards agentic AI. And then, of course, a little bit about what is Agentic AI, which I am happy that many of the really amazing speakers covered before me. So I would be just giving you a brief overview and its relevance of Agentic AI towards the healthcare. And why do we think that it could be revolutionizing healthcare in the coming years? Then I will be discussing some potential applications which are like a future view of where this field is going, that is agentic AI in healthcare. And then some real world applications, that is some applications that are already in place, already in the market, and is being, I would say, like produced by companies, and they're being used by people, like real people. So these are some real world applications we will be discussing. And then finally, I will conclude with some challenges, mostly coming from the ethical side, and some best practices for organizations who are trying to adopt agentic AI workflows for healthcare. So this is about me. I'm an associate professor in AI and robotics at this institute dedicated towards AI and data science. It is close to Paris, and it's called City. I got my PhD in electrical engineering from the University of Galway in Ireland in 2019. And currently in my position, I'm teaching courses and supervising students in the fields of deep learning, computer vision, explainable AI, AI for health, human-computer interactions, and so on. And my research interests are in robotics, AI for health, assistive technologies, and ethical and fair AI. So to start with AI algorithms in the healthcare, or in the healthcare domain. So actually, AI has been having a very good relationship with the domain of healthcare. Why am I saying this? Because healthcare, what the kind of data, the kind of challenges, the kind of scientific depth it provides, it gives the opportunity for the development of, or it gave the opportunity to develop very sophisticated artificial intelligence models. Because life sciences, the questions are challenging. They are sometimes very close to human lives. The life science provides like a lot of possibilities for exploration in the data domain. Therefore, a lot of breakthroughs in the domain of AI came from the domain of clinical science and healthcare, as well as a lot of developments in healthcare. For example, in diagnostics, drug discovery, treatment planning, these fields got a lot of benefits by adopting AI in their workflows. So this beautiful synergy between healthcare data and AI capabilities, it continues to like build on the innovation aspect as well as the applicability, the usefulness aspects, and it has been like one of the major areas of AI application in the past few years. So as I said, like some of the main domains where AI has been used in the field of healthcare, these are some of the examples, like predictive analytics, that is predicting, for example, the COVID pandemic. A lot of research went on to predict the surge of the pandemic and in which direction is it going in terms of the number of cases and so on. Medical image analysis, for example, understanding if there is a tumor in a radiology image or not. Clinical decision support, this is mostly for patients to decide what kind of medication or the dosage of medication they are needing. To patient monitoring, if there is a patient who is residing remotely from a clinic, it is possible with the help of some added peripherals like cameras and sensors to use AI models running on the cloud to monitor their health status. Then there is the focus towards personalized treatment. That is, every person is different. Their biological properties are different. So one medicine cannot fit everyone. So there comes the idea of personalized treatment. Then came recently the field of natural language processing, and which also gave rise to like analyzing health records, electronic health records that are produced in mass numbers by different hospitals and clinics. So these AI models were specifically targeted towards these kind of electronic health records. And then now it is still under research, that is assisted living with the help of AI models, that is virtual health assistants who will be your companion, your virtual companion to assist you with medical or life support advice. And then operational efficiency, that is in the field of medical and clinical activities, there's a lot of human activity going on, a lot of documentation going on, and there is a huge department managing, like a huge body of people managing these kind of operations. And AI actually has been used to streamline or like pace up many of these domains of within which comes not directly towards the medicinal or biological side, but more towards the management of healthcare systems. So this is like a overview of where AI has found applications. Just minded that this is not that old. This field is only, I would say, 5 to 6 years old, and within that time span, AI has been taking part in all these aspects of healthcare in our society. This is some, I would say, some excerpts from my personal research that I have been doing over the years. So I spent a few years and I'm still in teaching AI for health, and I'm still continuing my research in AI for health. But I actually worked in several projects where AI models have been used for addressing a health challenge or addressing medical conditions. For example, I worked at the Paris Brain Institute between 2021 to 2023, where I worked with Alzheimer's disease data sets. So these were large data sets of brain tissue images showing signs or biomarkers of Alzheimer's disease, which are typically protein deposits. Sometimes they're very hard to identify accurately by human observers or clinicians. So my project was about applying a deep learning model to automatically segment this kind of biomedical, I would say biological imagery. And we saw that compared to a human observer, the AI model, which was a simple unit, if you are familiar with computer vision, you will know the model of unit. This simple model could actually accurately segment the protein biomarkers with better accuracy and better consistency than human clinicians. And then using this approach, that is of deep learning based segmentation of these histopathology images, as we call them, because they are from the brain tissue. So these are like tissue images taken from the brain of a dead person who had Alzheimer's when they were living. So using these deep learning models for extracting automatically these biomarkers, we could build actually a workflow to simplify the lives of clinicians who probably have to annotate these images. Like there are around 5 to 6,000 of these protein deposit biomarkers per image, and imagine there's a data set of thousands of such slides. So we developed a protocol to streamline the processes of clinicians who are responsible for annotating these kind of histopathological images. So that was one application of AI in health domain. And then another project I worked on was at Institut Pasteur in Paris. This was about using AI for drug discovery. Again, a simple AI model was used for identifying binding sites in protein molecules, that is where a drug will bind with the protein. When you build a medicine, when you build a drug, this is the first thing to identify, that is where or whether it is possible for two molecules to bind so that the medicine can take effect. So this was a deep learning and another application, but in the field of drug discovery. And again, I couldn't work with AlphaFold during that project, but again, AlphaFold is one landmark discovery in the field of, I would say, like drug development, which was built by Google DeepMind, and which actually like converts the sequences into actual 3D structures. So these were some of the applications of deep learning for or AI for health that I worked on personally. Some more, I built a project series which actually involved using transformer models. So these are like the vision transformer models for brain MRI classification. Now, brain MRIs can show signs of tumor, and some of them could be very visible and very easily identifiable to the human eye. So it's easy for clinicians to annotate them very easily and for patients to really start treatment very soon. But some tumors, they are very difficult and they are very like intricate within the MRI imaging. So, and for that, like more and more AI models are being adopted for identifying some critical tumors, brain tumors. So this was one project where I used transformer models, which are actually the, as we all know probably here, the transformers are the first language models that actually had also some vision related applications. So this was one project just to detect tumors from brain imaging. And another one that I worked was about using simpler models, less complex models than transformers, such as basic classifiers to detect COVID in the chest regions. And this actually project I was motivated started to work during the COVID times, when there was COVID all around the world. And this actually has showed the potential that AI models can be used for very fast and accurate determination of whether somebody has COVID or not. And that could be a very I would say, altering decision for a clinician or a radiologist to do, because the more time they take, the more time the patient is losing. So this was a big topic during the COVID about how to use AI for rapid and accurate identification of COVID signatures. So I just wanted to give this overview of what are the different real applications that I have myself worked with, and I have seen AI algorithms, how they are trained, how they perform, their level of accuracy, the level of performance, which I have witnessed myself in different projects in healthcare. Apart from this, so this was a bit of a first-hand experience for me, but apart from this, what I have read in literature is that in parallel to the things that I worked on, there has been really big innovations in the field of AI for healthcare. That is, for example, Google DeepMind's AI, which has been used for retinal disease detection, even cancer detection, then healthcare records. There are like a huge amount of healthcare records produced by different hospitals. Now they are processed by AI models to do it in a more automated and accurate fashion, so that not to depend on human effort and human consistency. And then in drug discovery, the AlphaFold is legendary. That's why they got the Nobel Prize in the last year in chemistry. And then there was the IBM Watson for oncology, and several AI-based healthcare apps, for example, targeting mental health or detecting a person's activities in a household setting. So, I mean, the reason for discussing this aspect is to say, like, AI has got into many different domains in healthcare. And some of them has been so successful, literally groundbreaking and bringing in new frontiers in the domain of healthcare, both technology-wise and utility-wise. So this is where we stood in 2024. That is, AI with its traditional set of algorithms was already having a big impact in commercial field. More and more companies like GE, Siemens, they were adopting AI in their workflows, and the AI in healthcare market actually has quite a big contribution, even financially, commercially. And majority of them come from robotic assistants, then robotic surgery, then cybersecurity, for example, predicting dosage for treating any particular disease. So basically, just to say that by 2024, we had a very solid footing of AI in the healthcare industry as well as research. So what we observed in 2024, standing in 2024, is that we were slowly transitioning these terms like generative AI, LLMs, agentic AI. They were slowly coming up. And at the same time, we who have been working on AI since, I would say, around a decade ago, around from the years of 2015 to 16, we had in our knowledge repertoire, that is our knowledge base, these traditional AI models. Okay. So these traditional models, which depend on predefined rules, supervised learning, and this fixed decision-making framework. So, for example, these models, they had some very good qualities. Of course, that's why they came in the commercial domain. But they had some very good performances in tasks like task automation. So if you set a few rules for them, they used to follow. Okay, there's a sequence to follow. So they execute the workflow like that. Pattern recognition. If you train with sufficient amount of data, cancers, tumors were being detected very, I would say, with a lot of accuracy by these models. Then there is predictive analytics. It was used in many, I would say, disease prediction domains. And then rule-based execution, that is simple rule-based models which could be used for example, clinical decision-making. But at the same time, it was observable at the same time, that is, these traditional AI models, they suffered from, of course, some shortcomings. That is, reduced flexibility in dynamic environments. A simple example is if you have a model trained on cancer data, and it has been trained on a big data set, sufficiently big. There is no limit to the size of a data set. But if there's a new type of cancer image that the model hasn't seen before, it, of course, like there is a certain chance that it will probably create a misprediction. So there is a when the environment is dynamic, there is new data coming all the time. There is like a constraint for these models. Then there is limited autonomy. Okay, so these models, they didn't run by themselves. There has to be a clinician. That's why no AI workflow in healthcare was completely autonomous. It was always like a human in the loop. So there has always had to be a clinician or a radiologist or even an engineer somewhere launching the process. Once there's a patient, once there's a case, once there's some data to analyze, somebody was launching the process or a set of processes, and then the models could give an answer. And then lack of context, that is, the models were very like agnostic. They didn't really consider in what context these data that they were getting would matter. For example, when I was working with Alzheimer's disease, there were patients who also had Parkinson's at the same time, but the AI models failed when both these signatures of protein signatures between Alzheimer's and Parkinson's, they occurred together. So they had no sense of this context aspect. So these were some of the shortcomings or limitations of traditional AI models that has been used until now. I would say now because we are still using them, that has been observed, which actually brings us to today, where we are slowly identifying it's standing in 2025. We have some new demands, that is the current healthcare industry or the current healthcare in the society. There are several new demands that the people, the clinicians, the hospitals, the doctors, they have. So, for example, what are the demands that our current healthcare needs? That is goal orientation and planning. So we no longer just want to specify some workflow. We want to achieve a goal, and we want our system to plan the roadmap towards that goal. Okay, we won't be specifying the roadmap. We just would start with the case, and we want the outcome, and the intermediate planning, we expect our system to do it themselves. Then autonomy and proactivity. This part is very important because, as I said, like AI models, they do not launch by themselves. Somebody has to launch it, and depending on that person's expertise, you can either launch it in the correct time or in the wrong time, in the correct way or the wrong way. So there is no proactivity. So we want our systems to be alive and agile. Then there is interactivity and collaboration. Again, our models are very fixed. For example, a model which has been trained on, for example, radiology data set, it rarely probably will consider what I would say another omics or another type of radiology data set would provide the information. That is, there is no interconnection between these models to discuss between themselves that maybe we could share some information to give a better diagnosis. So this part, interactiveness and collaboration, is missing. And learning and adaptation, this is a huge problem. That's why in the previous domain of previous AI models, there was this online training, there is this real-time training, real-time feedback, these type of strategies were being used. But still, when the patient volume grows and when the number of data is like every day, it's a new data that these models are encountering, there is a lack of adaptation, which we need actually now, because the patient volume has increased. Everyone wants to get these facilities to themselves. So the models that you build today has to adapt to a complete new population tomorrow. So this is a requirement in today's healthcare. So I will rapidly go to Agentic AI, although like I wouldn't be saying anything super new that the previous speakers haven't spoken, but just to put in context about some of features of Agentic AI, so that the audience relates what features of Agentic AI are actually relevant for healthcare. That's why I thought I would put a couple of slides. So Agentic AI, I wouldn't be giving the definitions. We have a very knowledgeable audience. So these are AI systems that behave as independent agents with the ability to set and pursue goal autonomously, learn from interactions with their environment, make some decisions and take actions without continuous supervision, and collaborate with humans or other agents. So just to mention that these are some of the aspects that, as I told you, where our current healthcare scenario is, these are very fitting. Our current healthcare scenario actually needs these kind of qualities in an AI model. So these systems are designed to act like proactively, adaptively. So exactly what the healthcare domain needs is what is the Agentic AI systems are providing. So these Agentic AI systems learn from real-world interactions, can respond dynamically to complex clinical administrative situations. So pretty much like people are thinking, this is exactly what I needed. This is exactly what was lacking in the traditional models, that the Agentic AI, at least what is being told about the Agentic AI system, that they are capable of doing this, they are very well fitted with the requirements of current healthcare. As I told you, healthcare and AI always had a very good relationship, and it is still seen in this era of Agentic AI. I would just say a bit about historical developments. That is, I mean, again, everyone probably knows here that is pre-2023. There was mostly theoretical work on AI agents. Reinforcement learning, multi-agent systems were slowly being developed conceptually. In 2023, we had OpenAI, Google DeepMind. These labs began emphasizing on this agent-like behavior, and then they were more exploring these generative models, autonomous agents like that. And the real innovation in agentic AI actually was starting from late 2023 to early 2024 and onwards. That is, the agentic AI term was coined around this time. It was being adopted in academic, commercial spheres and policymakers' books. And they were found to have these kind of capabilities that they can initiate, plan, and execute tasks independently, which was a big plus for AI models that we had so far. And in 2024, we currently have a full agentic AI bloom, like with companies like OpenAI, Microsoft, Anthropic, Amazon, actively investing in research and development in this field. So just to summarize, again, this is like a very, I would say, like a dense slide with a lot of things. Just a few things I want to mention that so that you can relate again how healthcare and agentic AI can come together. So what are the capabilities of agentic AI that are attractive for the healthcare domain? That is independent thinking. That is agentic AI systems, as claimed by the researchers who are developing them, that is they process complex information without human help. Then they have the capability of decision making. So they can choose the best action based on a current situation. Adaptability, learning from experience, goal-oriented actions, self-directed learning, contextual understanding, strategic planning, environmental interaction. All these features that the agentic AI researchers are highlighting that, okay, our system can do this is exactly what the healthcare industry and research needs. A little bit of how agentic AI works, but on a superficial level, not in the engineering level, but how a clinician or a healthcare worker or a user who needs some healthcare support, how they can use an agentic AI system. So, for example, a user provides instruction, that is, they engage first with the agentic AI system with a natural language prompt. So they do not have to be agentic AI specialists. They can just work like they are speaking to their clinician, nurse, or their doctor. So it's like speaking to a trusted agent, and then the system interprets. So this is the I would say, role of the system within the agentic AI environment to interpret what the patient or the user asked for, what is their query. And then starting from that is the start point of the functioning of the agentic AI system for healthcare. And then the agent takes over. The agentic AI system is supposed to take over, plan, allocate, and execute the goal of what the user wanted. So they basically, the system, which actually I think our previous speakers discussed, that it is sometimes the core foundational model is just an LLM, like a transformer model or like GPT-4, like that. So this system then converts this user input prompt into a workflow. So this is what is attractive for the healthcare domain. That is, the user, as you can imagine, the healthcare is a domain where anyone can be a user. You cannot design a system just for technical specialists. It has to be super generic. So that is ideal for this case of agentic AI, that you just give a prompt and it is then converted into a workflow. That is, you then break down it into tasks, assign it to different, I would say, components, and then execute it until the final goal is achieved. So then agent system also, like, it not only executes the function, but it also iteratively improves itself. The decision making is improved, the response is improved, like that. And finally, the agent executes the final action. So the interaction or the responsibility of the user is only to provide the prompt. And this is actually very attractive towards the healthcare, because they want to make the systems very generic, less effort to interact with the system, less prompts, but still the goal gets executed. So this is how agentic AI, it's a generic workflow, but this is something that is related to the healthcare domain. I would skip this slide because we already discussed this, I think, during the previous talks, where agentic AI, generative AI, and traditional AI, they vary, where they differ. Although generative AI is, I would say, just the precursor of agentic AI, because that's where all these transformer models, they started. But still, agentic AI actually takes it a bit forward, actually a lot forward. That is, the agentic AI's primary function is goal-oriented action and decision making, whereas generative AI stops at content generation. That is, it can, if you give it a prompt, it can generate some text, code, image, etc. And traditional AI, I think it's even lesser complex, I would say. It just focuses on automating some repetitive tasks, like just a prediction. It will do a prediction. It can do an analysis, but only when it is like asked to do it. And then autonomy, very low autonomy from the traditional AI parts. As I said, it has to be launched. AI model, traditional AI model doesn't launch itself. Generative AI, it could be variable. It could be based on user prompts, but agentic AI, that is one of the highlights why agentic AI is interesting in healthcare, is that it has this property of autonomy. That is, it can work with minimal human oversight. And finally, learning. The agentic AI systems are built to learn from their actions. So this aspect of reinforced learning, improving through experience, is incorporated in the agentic AI, not so much in the traditional AI. That's why some AI models which have been trained a couple of years back may not be working at all in a current data set. I would again skip this slide because this is the difference between, I would go more into this theory of agentic AI versus AI agents. But just to say that agentic AI is actually like a system level architecture, which is goal oriented. And it is it brings together many components, starting from a brain to process the prompts, to memory, to executing components. So it's like a system level architecture that achieves some autonomy, a high degree of autonomy to complete a task. Whereas AI agents are built for specific purposes and they achieve those tasks. So this is like an overview of where do these two terminologies, which are sometimes used simultaneously, how they differ. And this is how I would say, from traditional AI, this is actually the core of my presentation, that how we are evolving from generic AI models towards agentic AI. And this has been the curve for that. That is, we started from task automation, which is typical for, I would say, traditional AI. We are going more towards problem solving. That is when we are including aspects like decision making, autonomy, less human supervision. So we are going towards a more problem solving, I would say, aspect of AI models as we are moving towards the agentic AI side. So and then I again come back. So I briefly detoured in the middle to talk about agentic AI aspects themselves, but how do we link agentic AI in healthcare? So again, as I said, just because of the properties that agentic AI has and the needs that healthcare has, that's why they can come together very successfully. So healthcare delivery today is shaped by rising expectations and mounting complexity. Complexity because we are trying to achieve or put together many different kinds of requirements. We just don't want to get a medication for a disease. We want a treatment plan. We want a projection of where the disease would be in the next few years. So the requirements in the healthcare field are more complex than it was before. And the rising expectations because we want them fast. We want them fast, we want them accurate, we want them at our doorstep, like that. So patients want faster access, real-time updates, and more control over their care journeys. It's not a simple doctor-patient interaction anymore. It's more like you plan my treatment for the next few years to come, like that. And it is so important because it is tied to my well-being. Stakeholders, which are basically the people who are building these systems, from health plan executives to regulators, they expect data-backed decisions and continuous improvement. So this is a requirement that is coming from the healthcare industry. Then health systems are managing a surge of real-time inputs from electronic health records because more and more hospitals and clinics are adopting AI workflows and also digital health workflows. So all the patients that used to be registered manually, their documentation was super manual, all of those patient workload is coming towards the digital analysis of the patient records. So you can imagine the load for these kind of automatic analysis, automatic prediction, these requirements are only increasing as we are adopting more and more technicalities in the healthcare domain. So basically, the speed, the scale, these are the two I would say reasons why the healthcare needs some advanced system at the moment. That is, the speed and scale requirements of modern healthcare are pushing the traditional system to their limit. For example, I can tell you regarding during COVID, the way the radiology data was analyzed, already it was mostly done by human radiologists. Some clinics or some, I would say, companies, they tried to include, I would say, AI-based workflows, but still it was found that it's not sufficient. Even AI-based workflows which were not adequately, I would say, implemented, they are still, I would say, lacking to cater to the huge amount of demand. Like that was one time when we saw how real healthcare demand, how strong it can be. Everyone wants a diagnosis within 2 days or 1 day. So that is real healthcare demand, and it is very hard for traditional digital health systems to cater to. In a world where timely, efficient, and accurate healthcare is vital, so this is the thing, that is a requirement, that is timely, efficient, and accurate healthcare is the need of the day. And that is why we are realizing that the traditional, even the AI models are not sufficient. We need more, because the need from the healthcare industry is driving this kind of requirements. So agentic AI systems, which have been, as we saw in our previous very good, I would say, speakers' presentations, that is, they have the capability to perceive, reason, decide, and act autonomously to achieve goals. This property actually is the main driver for bringing, I would say, agentic AI to the healthcare domain, that they can take these decisions, they can learn, they can perceive the future requirements like that. So basically we are moving. So the last line that we have over here on my slide is that we are moving from tool-like algorithms, very, I would say, like non-autonomous. It's a tool, it's useful, but it's still, I would say, it's just a tool. It's not a decision maker. Its utility is limited. So we are moving from tool-like algorithms to goal-directed elements. So this is how we are transitioning from like traditional ML AI to agentic AI side. So again, like just a bit of repetition, it could seem like, that is, what are the 3 key characteristics of agentic AI which are driving this change in healthcare domain, or change in approach towards a healthcare domain? That is agentic AI. First is the automation part. That is agentic AI automates tasks like, for example, a lot of hospital burden comes from staff scheduling. I told you, like the one part is the biological challenge, the other part is the management challenge. And a lot of this managing these huge databases, huge flow of patients are being effectively like targeted by agentic AI systems. I will give you real examples in a bit. So these agentic AI, with their property to automate many tasks and do them properly, not just rule-based automation, but knowledge-based automation, perception-based automation. So agentic AI, they are able to handle this kind of, we can use agentic AI properties to automate this kind of tasks like scheduling, patient documentation, and routine manual tasks that actually is a huge bottleneck in the healthcare industry, because a lot of delays are being caused by these kind of person errors, person delays, like that. So agentic AI, if they are sufficiently accurate, if they are sufficiently ethical, they can be used in this type of I would say applications. Real-time decision-making support. Because of these decision-making capabilities of agentic AI systems, they are projected, or they are thought about that, okay, they can support clinicians by providing real-time feedback about a medical condition. And adaptive learning, that is, they can adapt to changing circumstances. As I say, like biology is, like the beauty of biology is that it is so varied, it brings in so much diversity in the data set, that it could also become a challenge towards simple rule-based systems. So that's why we need the thing about adaptive learning. That is, we can adapt to changing circumstance, patient database, to different times points at which the data has been collected, like that. So yeah, a bit of summarizing of why, what are the benefits of agentic AI in healthcare. For example, they are projected to reduce error, accelerate the diagnosis process, analyze real-time data from wearable devices or any kind of sensor somebody is wearing, minimize errors, administrative delays, build treatment plans, improve patient outcomes, and improve the current like workflows which have been so far dependent on traditional ML models. I would just do a summary before moving on. It can again seem a bit repetitive. That is, agentic AI, why is it considered for as a breakthrough in healthcare? That is, it addresses the resource strain in healthcare by enabling faster and smarter decision making and expanding the system capacity, that the hospital systems can, or even the paperwork, the documentation systems, the medical systems that do that actual diagnosis, they can cater to more number of patients. Then adoption is growing across hospitals, research institutions, and life science organizations because of these capabilities. So agentic AI is actually being rapidly adopted by these public bodies. So then there is like rising patient and stakeholder expectations. That is, as I started this discussion with, that is, the main need is coming from the patients demanding more, I would say, faster access, personalized care, and data-driven decisions rather than very simple rule-based workflows that used to work before. Traditional systems, they cannot cater to these needs, obviously. And that's why with these attractive features of agentic AI systems, patients are also saying, okay, we need these features in our medical workflow. That is, somebody plans a treatment for us, somebody tells us in advance what can happen in my life in the next few years, like that. Again, coming to a more practical perspective, that although, as I said, from the history of agentic AI slide, that roughly the year of 2023 to 2024 saw the rise of agentic AI. At the moment, the market share is, I would say, market contribution is already high, in the order of several hundred millions have been invested in the US, and mostly these are agentic AI adoptions in the field done by healthcare companies, healthcare providers, academic and research institutes, like that. And like the growth is, the reason for this level of growth is that actually, which I will show in a bit, I have several slides showing the real use of agentic AI in healthcare workflows, because they are actually being successful. So more and more, there is more and more adoption, and it is a real-time almost statistics. That is, there's a real adoption of agentic AI in the healthcare domain, that companies are actually investing in this field. This is like a regional trend. How is it going for different countries? North America leads the market with a lot of investment in these companies. I will just show you some real examples in a bit. Because of course mostly the innovations and I would say like the openness to adoption is a lot in the Europe. As I'm here, I know that the regulations are like a lot. So but in Europe is still investing heavily, just followed by behind US, and also Asia Pacific and Latin America. Overall, there's a global, I would say, perspective about using this kind of agentic AI in future healthcare domains. It is seen all over the world. I will just talk about some potential applications. Minded, the potential are, it's like not hypothetical, but these are projected applications, that these are where agentic AI could be a really good, could have a really good impact in healthcare. But some of them may not be realized yet. I will come to the real examples just after these slides. So one potential application could be, this also gives you an idea, like just when I discussed before about how traditional AI has been used in healthcare, how agentic AI has the possibility to be part of different domains in healthcare. So one of them is clinical decision support system. So these usually, they work like a sequence, that something triggers like a process, that is maybe a patient has a high blood parameter, which triggers what kind of medication can be given to this patient based on their clinical history. So this is how a normal AI-based clinical decision support system works. Whereas with the adoption of agentic AI, what are the possibilities is that these agentic AI systems can connect to the electronic health records, which have a mountain of information. There's an ocean of information about a patient and their physical parameters. And then it also can connect to different types of unstructured patient data, which could be lab notes, some numerical data about the patient's body parameters, vitals, and as well as maybe some imaging results. So all sorts of information this agentic AI system can collect, assimilate, and then take a decision about what could be the possible, I would say, like dosage of medication, or what would be the next step to do. That is basically accumulating information from a lot of different healthcare, I would say, input sources. Then there is intelligent medical imaging analysis. Actually, traditional AI models have been quite successful in medical image analysis, with simple, very CNN type models achieving very good classification and segmentation accuracy. But agentic AI has a possibility of doing more. So what are those like additional advantages that we can like I would say perceive? That is, agentic AI models can automate the process of, like for example, you just submit maybe or upload a radiology image, and the agentic AI system can launch a full workflow starting from image cleaning, then followed by pre-processing, then segmentation, followed by understanding the tumor regions, and then maybe coupling with some other data. For example, it could be the chemical parameters which could be fused with the imaging information, and then taking a decision about, okay, what is the state of this tumor? Because tumor, just from the image, it gives a visual representation. It doesn't give any idea about its chemical composition. So agentic AI systems can have the possibility of doing this multimodal fusion with respect to medical imaging. Then there could be personalized virtual health assistants. For example, combining NLP and multimodal data, for example, text or data from calendars, from some body sensors. It could be like combining. Again, this is more about multimodal fusion of data coming from different sources and intelligent fusion of these data sources to predict something. For example, a person who needs more walking, more jogging, they can like the systems, these virtual assistants can actually combine data from different sources to create like a lifestyle planning for a person. Again, it is the more over the here the application is more about combining information, different types of information, and taking a autonomous and intelligent decision. Chronic disease management, it goes along the same lines actually. Again, it collects data. The idea is to collect data from multiple sources, creating a treatment plan, update the treatment plan, and keeping up following the treatment plan. So it's like a two-way procedure. It not only creates the treatment plan, but also it updates and takes feedback from the user. How is it working? Just like a real clinician would do. But just think that this could be done by an agentic AI framework. Then there is a remote patient monitoring, very similar application, but here if a person is like based remotely and they have like a bunch of sensors in their environment, then this data can be again like put together and intelligently, I would say, analyzed to understand the small to small or minute changes in lifestyle, minute changes in behavior, which could be a big support towards mental health improvement, or I would say protection. That is small signals can be picked up by the agents if they are working continuously and autonomously, and they can be processed to give the accurate kind of or regular and accurate feedback to the person. So these are some potential domains where agentic AI could be really successful. And the final is the administrative automation and claims processing. This is a very far shot from the biological and clinical side. This is absolutely about the management of health systems. That is, the revenue cycle management is one of the, like in the background of hospitals where we get treatments, works like a huge system of people managing all the data, payment, etc., in a human resource, etc. So like in those kind of fields, I mean, where it is resource critical, it is time critical, and you cannot afford to have errors in those kind of systems. Agentic AI actually has probably the biggest footprint till now, which I will show you through the next slides. That is revenue cycle management. It is a financial process that tracks patient interactions like appointment scheduling, final payment, booking, canceling, and then also like claim submission, claim denial, something like that. So these systems could benefit a lot from this kind of autonomous processing where we cannot tolerate delays, we cannot tolerate human errors, like that. So these are actually ideal scenarios for agentic AI systems to work, which I will this is just an example of how this kind of administrative automation in healthcare could be supported by agentic AI. That is, firstly, these agentic AI could extract structured data from the patient submitted documents like notes, discharge summaries, billing forms, and then they can match them with the required, I would say, healthcare standards or the procedure that a hospital follows, like payer compliance, some errors in the forms, like that. So imagine the whole workflow takes days because a human or a group of humans are involved, but this could be simplified, or I would say done more efficiently, if an agentic AI system could be built to automatize the work, and they don't get tired. So like they can work 24/7. I'm not talking about like replacing humans, but they could be a really good, clear, like I would say, support towards the whole procedure. Then some real world examples. So these are some projected examples. Research is ongoing in these fields that I just described, but there are still real world examples where agentic AI has been actually adopted by a company or an organization, which is actually in like usable at the moment by real people, which is amazing because this technology just came out last year, and now we have something like that uses agentic AI in a real user setting, in a commercial user setting. So you can see the level or the pace of growth in this kind of field. So number one is by AWS, by Amazon. Amazon actually has recognized the need for accelerating life sciences innovation with agentic AI. So it has actually released an open source toolkit on Amazon Bedrock featuring starter agents, supervisor agents tailored for healthcare and life sciences workflows. Typically, they are targeted towards clinical trials, biomarker discovery, drug discovery, like that. And so it has provided, like I found this like on their Amazon Amazon page that is this is actually a whole toolkit on, and they are letting people use it to build agents to like some healthcare related applications. So they have made it so ready for people to use and adopt to build different workflows. So it is already in place. So this is by Amazon. And see, there's already an article which says building AI agents using Bedrock agents. And this was actually targeted for healthcare applications. And they have a full article discussing how these agents can be used for life science research and development. Workday is another company. It's a US based company. I think it's quite popular. So it is advancing agentic AI in healthcare through something that they propose, that is agent system of record. Again, it goes towards the management side of healthcare, that is designed for environments where staffing, scheduling, and financial planning are tightly integrated. So agents operate on real-time data from HR and finance systems, supports critical operation decisions such as shift coverage of people who are working, managing labor costs, ensuring compliance with credential requirements. It is already in place. As I have put the, I would say, screenshot of a real article from Workday. So this agentic AI solution is already present. Then there is this company called Anterior, AI-powered workflow automation for clinicians. So this is built by clinicians to reduce the administrative burden in healthcare. Again, it goes towards the management side. So doctors, they spend a lot of time on desk work, that is handling documents, which they could actually use to improve treatment and patient care. So these kind of, I would say, patient management systems is proposed by Anterior. It's a US-based company. And they have created this AI agent or AI agent-based assistant named after Florence Nightingale, to streamline authorization processes and to automate repetitive tasks. And they have observed that this could change or reduce the review time from hours to days to a matter of few minutes. So this is like a real output from their company, which is actually available right now. Then there is a company called Epic. It is also, I think it's based in Verona, Wisconsin. So it is, again, embedding agentic logic into EHR, electronic health record system, to assist clinicians, summarize patient history, highlight key data before visits, designed to enhance clinical judgment. And also they are currently building things on care plan adaptation, medical imaging, medication safety. So it's in process, but it already has some agentic AI solutions in the field of healthcare. Home Care Delivered, another medical equipment supplier from Virginia. So it is again mostly focusing on the agentic AI for these administrative part, that is RPA, with agentic AI revolutionizing the revenue cycle. That is how the payments are processed and how quickly they can be delivered. So home care, so it transfers. The thing is, this result actually they observed that there is a processing time they could reduce by the efficiency of their agentic AI system. They could reduce the processing time by 95%, which is a huge, I would say, if you look for Home Care Delivered on Google, this result comes up again and again. But I hope this is I would say, sufficiently generic. And so if it is, then it reduces 95% of processing time in administrative tasks in healthcare, which is a huge, I would say, a breakthrough in the field of healthcare, I would say. And finally, I think Advantum Health, again, a Kentucky-based revenue management company. Again, they also showed a similar result, that is 40% reduction in staffing needs and basically faster processing of hospital documents. This is the whole idea of the company, but using agentic AI in their workflow. And I think another is Intermountain Health, another company from the US. It has been able to use its agentic AI with Microsoft Azure. As you saw, that Amazon is investing in it, Microsoft is investing in it. So it uses their agentic AI systems to reduce the administrative and documentation load so that staff can focus more on patient care. And they observed a call abandonment rate was dropping. So instead of human responders to calls, they use agentic AI. Now, I will come to the challenges and questions arising from these applications in a bit. So hold on. So the main idea of giving you these examples is that there has been adoption of agentic AI in healthcare workflows, as well as measurable impact. That is, people can see the difference that these agentic AI systems can make in the domain of healthcare. And finally, this company, it's called IQVIA. It has developed custom AI agents using NVIDIA platforms, and I think it is made for agentic AI workflows for clinical development. So it's not for administrative parts; it's more on the biological side for clinical trials and product launches. So it also launched very recently. So, I give you some real world examples where agentic AI has been adopted in healthcare and is already showing impacts. But let's look at what challenges there are. Of course, it's healthcare and AI. There will always be these questions about fairness, bias, ethics, and everything. So, what are the ethical challenges? I think our first speaker already talked a bit about this. So, this is about bias. So, all models can have biases. So, an agentic AI is not free from that. So, this is where also, like, it is not too different from a traditional AI model that it can have bias. So AI models can carry biases in just because it was trained on a certain data set, even they are capable of learning independently. And this can actually, so it's not just mental health, actually, this kind of bias can create huge problems. If it's managing a whole medical workflow, it's a whole healthcare workflow, and the model is biased, you can imagine the catastrophe. Okay, so AI model which is not effective for all populations or all type of users can create a huge problem if there is a wide scale adoption. So this is a check. This is a reality check. So it can lead to inaccurate health assessments and recommendations. So basically, since you are allowing the agentic AI to do a lot of the tasks which was done previously by separate systems or human in the loop, if you are allowing it to do all the workflow by itself, there is a chance that even a small amount of bias can create a lot of problems in the end result. Then there is, of course, data privacy and security concerns. Like, this is actually, health data is one of the most, I would say, privacy and security, I would say, sensitive data. And so it always, there's a question like, what kind of data is the agentic AI using? Is it should be allowed access, for example, for home monitoring or this assisted living or virtual assistants. It's what kind of data will you allow an agentic AI system to use? Would you allow the agent to use your data for training and to use it for another person? So these kind of privacy security concerns are a big minefield, because healthcare is literally the most privacy sensitive domain. Over reliance on AI and reduce human interaction. So when we visit a clinic, we meet a series of people who have different expertise, and of course at the end we get a result from that. But if we depend entirely, if we leave the whole workflow, which is also what brings agentic AI to healthcare, that is, we want to automate the full workflow, but is it really good? Because then we are having an over reliance on AI. That is, if some part of the AI fails, the whole workflow can break down. And reduce human interaction. That is, we probably, if these are wide scale adopted, then we won't be meeting real people anymore, and we won't be, and as you can imagine, there is a knowledge ceiling for these kind of systems. So we won't be having people in the loop. So in order to automatize many things, we will lose the human touch from the systems. Again, ethical and regulatory challenges. This is huge, because I checked, I don't know how many companies mention this in their website, because I showed you 6 to 7 real life examples of companies adopting agentic AI, but only one I could find, or maybe 1 or 2, which mentions that they are compliant with HIPAA. HIPAA is a regulation in the US, also I think it's globally, that is that maintains these regulatory requirements for AI and digital health. And so how many of these requirements are being satisfied? So this is a big question in ethical and regulatory challenges. And limited emotional intelligence and context awareness. This is something we talk every day. Is the AI that we have, is the ChatGPT with whom we almost talk a lot every day, is it sentient? Can it feel emotion sometimes, which is very important in the case of healthcare, because when you talk with a real person, empathy comes in, their decision human, I would say, morals comes in. But will that be compromised in the case of agentic AI? So these kind of questions also come in. So other practical challenges rather than ethical and I would say regulatory ones, that is trust and transparency. That is something I asked after the first speaker, that is, how ready are industries and users to these kind of systems? Will the people trust? Because it's healthcare, it's so sensitive, it's related to my well-being, my life. Will I trust such a system to take so many decisions on my behalf? Then there is autonomy versus oversight. That how much freedom do you want to give these agents to take decisions on behalf of a doctor or yourself? Bias and safety, something we already discussed. That is, if there is a little bit of bias in one component, the whole workflow can become problematic. And human agent collaborations. Then, for example, if we cannot have a fully agentic workflow, but there will be clinicians at some point, how well are these two elements working together? How well are clinicians working with agents? Do they trust each other? Do they, I would say, work well together? So these kind of practical challenges also exist. I would like to conclude my talk with just some best practice, but this is just when we have only started adopting agentic AI for healthcare. These are some of the projected, again, best practices that could be useful for developers of agentic AI for healthcare systems and companies. So, for example, define clear AI objectives and implementation scope. Identify where exactly agentic AI will fit in. Don't say that agentic AI will do everything in the workflow. And then establish measurable targets, such as what level of accuracy you want to achieve, what is the user satisfaction, if you have any metric for that. So make it tightly guardrailed, I would say. Invest in workforce readiness. This is something, this was in my question actually, how ready are we to adopt these systems in our lives, which is more sensitive in the case of healthcare. Ensure smooth workflow integration, again related to something I related to my first question, that is many companies are which produce this kind of clinical software or clinical workflows. How ready are they to adopt agentic AI suddenly, because it's a new technology, but how long will it take to adopt them in regular workflows? And finally, start with the pilot deployment, which is, of course, always a good idea. That is, we start small, we do a test study, and then see the effectiveness, the challenges, the ethical problems, and then we think about mass scale deployment. Then I would just summarize, that is agentic reasoning, which is actually the backbone for bringing agentic AI into healthcare, equips AI systems to respond intelligently to change. Which is basically why we are transitioning from traditional ML to agentic AI. Then agentic AI enables context-aware decision-making. It streamlines daily clinical complexity, something that is actually being taken up by companies. This requirement has been identified and being taken up by companies to produce those products by the different use cases I showed you. Then supports clinicians by reducing cognitive load. And in high-stake care settings, rapid context-driven AI action is not just helpful. For example, in critical disease management, or in cases of COVID, where you're managing large number of patients who need very fast outcomes, these could be a real game changer. So I would there's a little bit of future, because we are still actually, as we are talking, some new, I would say, agentic AI developments are happening. So the future is literally being built at the moment. So again, I think it was mentioned in a previous presentation, that is, we have to treat agentic AI as colleagues and not just tools, which is the whole point of switching from traditional ML to agentic AI. That is augmentation of healthcare teams and not replacement. So this is always, we have a AI for healthcare talk, we finish it saying we are not trying to replace clinicians, we are trying to help you. Then there is personalized medicine and lifelong care, that is continuously adapting agents throughout a person's lifetime. This is actually a really long lifetime, really long time to adapt a system and accordingly take decisions throughout a lifetime, which is like a future goal. And then interoperability of healthcare agents, that is, we need to build an ecosystem of these kind of agentic AI systems and not just tailored very small scale solutions, so that why it can cater to many different aspects of the healthcare domain. So thank you very much, and I hope to get some questions, and yeah.
Thank you, Dr. Kar. Any questions, anyone? I think we are slightly running out of time, but I think there's time for one or two questions. Okay, I'll probably start with one.
Yes.
So I was wondering if you can provide some insights into any algorithms or any insights into agent coordination in multi-agent systems for healthcare.
So far, the one that I found with Bedrock, it has the Amazon Nova model. That is another problem I noticed. I mean, of course, the research papers, they do tell what kind of models they have used, but these companies, they stop at the description. So their models are not that open to explore. That is, they do not give very good specifications of what exactly they are using in their agentic AI workflows. But I mean, of course, there has to be a transformer. There has to be some RAG-based retrieval system, and then there will be some memory element like a vector database like that. But exactly pinpointing, I only could find out about AWS, which uses the Nova model.
Like for instance, suppose if there are any conflicts or contradictions between agents' goals or decisions, how are they handled?
I think I would, that's a fantastic question, but I don't think they have reached this level of sophistication, at least in application area. They so far are like trying to create these simple agentic AI just to automate. They are mostly focusing towards the functional aspect, but these multi-agent collaboration conflicts, these are, I would say, more about the future and ongoing works. Like, I haven't seen, like, this is a very, like, I would say, potential question that can arise in multi-agent systems, but I haven't seen so much discussions about it, I guess. But
Can I ask a question?
sure.
Yeah.
So, what do you see as a main distinction between agentic AI generally versus agentic AI in healthcare? That kind of makes it a special case, or do you think we can just, piggyback off of generic AI, agentic AI innovations?
Absolutely, because generative AI was, I would say, like the starting point, and if you keep building around it, only thing is the generative AI just produces something in response to your prompt. But this autonomous, I would say, action, like just to think about the decision making aspect, that is, you use the agentic AI system to not only generate some output, but also to take some decisions without being prompted. So this autonomy aspect is new in case of agentic AI. Or something,
Sorry,
it's a plus.
what I meant was agentic AI in all the other fields versus agentic AI in healthcare. Like, what is the difference? Do you see any like special cases?
So far, actually, I have only seen these applications. One, I think it will be more interesting when it comes to the life science side of healthcare. So far, as I told you, the most examples I have seen is in the document management, auto process flow automation part. So I think it is very much, I would say, parallel to what is happening in other domains. So it has been just transported from other automation workflows to the healthcare. But once it comes to the actual healthcare that is dealing with multimodal health data, then it will be more unique towards the healthcare, because there you are coming from, I would say, different people, different populations, different types of imaging, multimodal fusion. This will be unique in healthcare, or maybe in some other domain, but at least it won't be as generic as process automation. Process automation is heavily, I would say, taking from other fields of agentic AI, where they are mostly focused on the automation itself.
Makes sense. Thanks.
Okay, I think there are no other questions. So thanks a lot, Dr. Kar, for joining us and sharing your insights. So we'll now move on to the next topic. The speaker is Dr. Utku Kose. He is joining us from Turkey. So thanks for joining, Dr. Kose, and please take it away.
Yeah, thank you, dear doctor. I think I'm audible. Thanks
Yes.
for inviting me. Such a great event. First of all, I'd like to congratulate to everybody enrolling in this event, part of the International Conference of Applied Data Science. And I'd like to thank you to you, dear Dr. Pendyala, and also Rahul Raja for inviting me. And so far, we have listened to great topics and also the valuable speakers just all indicated the importance of the agentic AI, and even the last presentation by Dr. Kar indicated the importance of the agentic AI in healthcare. Why I'm saying all of these things, because my expertise is with the AI, and I'm also enrolled in research with AI applications for healthcare and also biomedical problems, of course. So I'm a professor from Süleyman Demirel University in Turkey, and as I said before, I'm also interested in the biomedical and healthcare-oriented applications of AI. So the last presentation by also Dr. Kar was great, and also I'd like to also thank the other keynote speakers who talked about agentic AI and different aspects, even including the business oriented outcomes and applications. So in my presentation, I'll be talking about the trustworthiness. So there were some things discussed by the other speakers, of course, but I will be trying to diving into the deeper aspects of the trustworthiness in the context of the agentic AI. So I hope you will all enjoy my session. Okay. Anyway, I'm talking too much, so I hope I will use the time efficiently. Sorry about that. I'm sharing my screen, so I think you are all able to see my presentation. Okay. So, first of all, in my presentation, I'll be talking about what is agentic AI, but I will be passing these things briefly because the other speakers already talked about this. I will be talking more about the trustworthiness and the factors affecting the way of the trustworthiness in AI. And also, I will be talking about the risks in terms of agentic AI applications, considering the different aspects, different risk mechanisms which having potentials. Also, the speakers also indicated and pointed some of them, but I will be trying to give more information about the potential risks here. And I will talking about solutions and some perspectives which may be effective for dealing with the risks in terms of agentic AI and ensuring the trustworthiness. Of course, I will talking about open problems and give some perspectives for the future. And at the end, I will be taking your valuable questions. Okay, so sorry about that. Okay, so I'm passing this slide briefly actually because we already know about that the agentic AI is all about intelligent systems which are able to interact with the environment and make autonomous decisions and behave in a goal-oriented manner. So we can just say that they are all about the proactive AI, which means that we ensure the independence in terms of aims and decision making, and there's a continuous learning, of course, and it's all active interaction. It's about the active interaction with the environment, and also we can also talk about the high autonomy when we compare with the reactive AI, which is dependent in terms of aims, decision making, and also the applications when we consider the level of autonomy and limited interaction with the environment, and also of course the learning is also limited when we consider the reactive AI applications. And examples of the reactive AI includes some applications such as object detection or diagnosis or spam filtering or video gaming systems, all include the reactive AI. Actually, most of the AI applications we know as traditional touch to the fields, we know that they are reactive AI, and after the advancements in terms of the LLMs and also that the generative AI rising over the shoulders of the LLMs, of course, opened the new views towards the high autonomy, which can be seen in terms of the autonomous vehicles or robotic systems which have autonomous capabilities, and also, of course, LLM systems which are able to run in the context of the different application areas, as pointed by the previous speakers, as you know. So it's all about the related aspects shaping the way of the independence in the decision making and shaping the aims during the flow, actually. Okay. So there's a difference between the AI agent and agentic AI, of course. AI agent describes a system's ability to interact with its environment, but agentic AI is something new, as pointed by Dr. Kar also. It's a very new concept, and it's more advanced from the AI agent, and it's all capable of making independent decisions and exercising the initiative in terms of its goals. So we can say that agentic AI is a subset of the AI agent. So in terms of the typical AI agentic workflows, we can talk about the reinforcement learning agents like the learning through trial and error, like the lifelong learning is happening in humans, so it's all causes improvements in terms of decision making over time, like considering the AlphaGo, as as an example of the application in this context. So there are multi-agent systems, of course, but with the agented AI, they are all about the agents working together for more complex problem solving, like the autonomous vehicle fleets, for example, or we know about robotic AI agents which enable autonomous movement and interaction in terms of the different real-world applications, like considering the warehouse robots or the other robotic systems which are running maybe in a factory or other environments, as you know. So, of course, the conversation AI agents is one of the most critical example of the agented AI, as we know them from the power chatbots or virtual assistants for the ensuring the NLP-oriented interactions with the user, like considering the ChatGPT, Siri, Alexa, or other applications. Of course, Dr. Kar also indicated or showed the AI agented workflow. You know that we have the natural language inputs, interpretation and reasoning, workflow generation and execution throughout the learning and course correction. And at the end, we have the output or outcome. And this is a typical AI agented workflow you can be already see from the literature. And let's see if the feature will be something giving something more advanced or innovative in terms of the AI agentic workflow. But this is the most essential view of the traditional workflow, which can be seen in terms of AI agented-oriented applications. Okay, so when we come the exact point in my speech, I would like to first of all indicate that in terms of intelligence systems, trust is not equal to accuracy. It's not equal to success. So we know that today's intelligence systems ensure great findings or the outcomes, as you know, and also they have very low errors in terms of different metrics, and they ensure almost 100 success rates in different applications or tasks, even for the more complicated tasks. And considering even the medical or biomedical applications, as I am enrolled in this research area, as also pointed by Dr. Kar, there are lots of very nice and great applications which cause some debates in terms of comparing doctors or physicians or the other experts, healthcare experts, with the AI-oriented systems. But we should be saying that this is not enough for trust, because people only use or accept systems they trust. Regulations and public acceptance are based on trust. So this causes the new term of the trustworthiness in AI. It's all about the AI systems earn human trust by running transparently, ethically, and consistently, also securely. So because of the many debates which appeared after the rise of especially that deep learning models, and also considering the latest advancements in terms of the generative AI with the wind of the LLMs, as you know, the trustworthiness in AI is the more critical concept, which is associated with not only technical fields but also societal fields. And so because of this, there are lots of research works or based on the defining the regulations and getting some feedback from public, and also trying to establish technical aspects in terms of the intelligence systems which are capable of the reading or being adaptive to the regulations, which are also tried to be global or universal, I mean. So there are lots of debates, there are lots of things ongoing in terms of the trustworthiness concept, but in terms of trustworthiness in AI, it's more about the different aspects which are already associated with the human values, but we try to establish the technical definitions or modeling when it comes to the AI systems, which are actually a product by the human. So, according to US NIST or European Commission or OECD, there are some frameworks, some regulations which are already defined. So, by combining all of these, the works or the frameworks, we can say that there are some dimensions which are covered under the trustworthiness value in terms of a typical intelligence system. So we can say that if we try to understand understand the trustworthiness level of a typical intelligence system, we should be understanding how it meets with the dimensions such as safety and robustness, or transparency and explainability, fairness, privacy, data governance, security, and also accountability. So by combining all of these dimensions, we should be sure about the trustworthiness level of a typical AI. So, but ensuring this trustworthiness is not an easy thing because, as you know, there are black box systems, black box models with the rise of the deep learning and the hybrid AI models. The black box nature is a reality in today's AI systems. So modern systems rely on the great number of the parameters. So it is somehow, not somehow actually, it's already difficult to interpret or explain their decisions by considering the connections between or among the input data and the output or outcomes. So we cannot figure out how to establish the bridge between the input and the output. So it's difficult. So we just call such models, such systems as the black box systems. Also, the data-based biases and unfairness is a real thing in today's AI systems because such systems tend to reproduce or reinforce the biases of the data they were trained on. So we should be careful about these aspects. It's already a reality, as you already know, that there are lots of stories on the background in the past. Today, there are more solutions, more different mechanisms to deal with the bias factor, but it was a reality in terms of the real applications of AI in the past, causing lots of problems. But it's also still a reality in terms of the trustworthiness in AI-based systems. Also, inconsistent and unpredictable behaviors are very critical because in learning or autonomous systems, small environmental changes can cause large differences in behavior, like a butterfly effect, as you know. So also there is the weakness of the human control. Humans can tend to overconfident in the system's decisions, and we call that as the automation bias. Or humans can act out of duty, which is called as out of the loop effect. So this causes a weakness caused by the human factor. So it's also a problem in terms of ensuring the trustworthiness in AI systems. And there's also chain of accountability and responsibility because there are lots of people who are responsible for the developing the systems, testing them, providing them, selling them, and also there are lots of users, as you know, and there are the infrastructures which are already used for the making these systems sustainable enough. So there's a great level of the chain for the accountability and responsibility. So we need to be careful about the checking the trustworthiness level when we consider that there's the chain of such accountability and responsibility in terms of the different stakeholders taking part in the AI systems establishment and employment. Yes. So when it comes to the agentic AI, I already talked about the trustworthiness in terms of AI or intelligent systems. But when we talk about the agentic AI, as already discussed by the valuable speakers before me, there are lots of things ongoing, different chains and different things we do not have any idea about how to deal with them because of the great amount of that agentic AI factors and the things already ongoing very fast in especially last 3 or 5 years, I can say. So, but still we know about some risks, but we should be also always thinking about the more risk factors in the future when we consider the agentic AI, which are evolving in time and changing the way of the daily life and even the different sectors and fields. So, first of all, we should be know that the one essential risk in terms of agentic AI is the goal misalignment. We already experienced this in the different applications when we interact with ChatGPT, basically, and when we consider its feedback, sometimes we can understand that it's just all giving some different feedback by affected by some other factors in the prompt. So it's somehow a goal misalignment. Actually, such systems attempt to optimize a given goal internally, but may deviate from human intentions in the process. Like, for example, if we try to give a goal of make as much as income as possible, it may lead the system to use unethical ways like fraud or manipulation. So the AI understands the literal meaning of the goal, but not the context. It's a risk. And another risk is all about the false value internalization. So the agented AI, a typical agented AI, may exploit gaps in the goal description to perform its tasks in a technically correct but unintended manner. For example, when we ask to run fast in a simulation, the agent may develop deceptive strategies such as gaining speed while falling. So this indicates a disconnect between the formal goal and the actual goal. So it's all called as the false value internalization. And also chain effects and unpredictability. Because of the interaction of multiple agents or a single complex agent is already applicable for this risk factor, of course. And it's interact with the environment, of course. So unexpected behaviors may appear in time. So the system may deviate from human control by developing new strategies on its own because it's autonomous. It's affected by the environment. It's all having a more complex structure and mechanisms even when we consider the multi-agents, but even a single complex agent is enough for some chain effects and unpredictability in time. For example, in multi-agent scenario, and in terms of trade systems, agents can collaborate and implement manipulative pricing over the platform, which is affecting the user's decisions, of course. So also another risk is about the black box decisions and lack of explainability, because agented AI often use the LLMs, deep networks, or multi-component decision chains. It's difficult to explain how or why their decisions were made. So this causes a lack of trust and accountability, especially in critical systems. For example, lack of explainability may cause humans to trust a cancer diagnosis system, which actually tends to false decisions in long term. So this is very critical. And another risk is malicious use risk. Agented AI systems can be easily adapted for both beneficial and malicious purposes. Capabilities such as coding, vulnerability scanning, and social engineering already causing lots of stories. As you know, news, we are already hearing about them in time, so they can be used in cyber attacks and more such things, malicious intentions can cause more risks in terms of agented AI applications. And another risk factor is vulnerabilities in agent models or communication pipelines, because there are communication pipelines, as you know, within multi-agented systems, and these may have vulnerabilities which can be exploited with cyber attacks. So also an agent may have vulnerabilities in its model architecture. So both situations eventually may lead to further issues in terms of data and system security. So as you can see, there are more problems and the more potential bigger risks when it comes to the agented AI, except from the traditional AI models, which seems like a more basic systems when we compare with the high complexity level of the agented AI, which is evolving and greatly improving and advancing in time, even when I'm talking now. And during these days, as you know, from the news from the different companies already establishing the LLM-based agented AI flows. And so the more things are just come to be real in time in the future when it comes to the further risks and the more different maybe variations of the risks in terms of the mechanisms, high level complexity level of the mechanisms included in the agented AI systems. Okay, so when it comes to solutions at this point, we can first of all talk about some approach for ensuring the trustworthiness. For example, value alignment can be a good solution for the problem in terms of the goal misalignment, as you know. The agented AI develops behavior based on its own goals, as you already know. So these goals must be compatible with human values. This topic is already having a long time period when it comes to research in terms of the AI or agent-based AI research studies. But in terms of the LLMs and the agented AI-based applications, it became a more critical solution wave. So when we consider this solution wave, it's all about aligning the aims to prevent some unethical goal optimization and divergence between human intention and the AI goal at the end. So it can be done through reinforcement learning with human feedback or providing guiding via principles like constitutional AI. We already see this in cloud models, for example. And also there's the human controlled loops. Probably you already heard about these, like human in the loop and human in the loop. So this is very critical for the agented AI because there is the full level of the autonomy. Although we still do not have the total full level of the autonomy still, it's just some time to go to reach to the full autonomy soon. So the risk increases the more we have the autonomous in terms of the intelligence systems, the more we have some more risks in terms of some unwanted outcomes from the intelligence system. So we have the human oversights, which should be included in the system design. So when we consider the human in the loop approach, it's all about that the human intervenes in the system's decision in advance, or we use the human in the loop. A human observes the system at this time, but intervenes with the system when necessary. So there is a slight difference between these different human-controlled loops, but they both have critical contributions in terms of reducing the risks in the agented AI when we consider today's advancements in terms of this high-level complexity of the decision making or planning, aim optimization, or the task performing throughout the different chains of the agents, especially multi-agent based agented AI applications. Okay, so I would like to show you an example of the process for the reinforcement learning from human feedback. It's an example provided by the data science dojo. So it's all considering a scenario from the Reddit. For example, first of all, we collect the human feedback by getting some samples from the Reddit posts. And there are some various policies which are used to sample set of the summaries. And two summaries are selected for evaluation, and the human, just a human, judges which is a better summary of the original post. And after this, a post with the two summaries judged by a human are fed in the reward model. So the reward model calculates the rewards, which we can call as briefly as R for each summary, and the loss is calculated based on the rewards and human label, and it's all used to update the reward model at the end. So finally, in the last stage, we train policy with the PPO. approach. A new post is sampled from the dataset, for example. So the policy, just the policy system generates a summary for the posts, and the reward model calculates the reward for the summary, and the reward is used to update the policy via PPO technique or mechanism, I can say. So in this way, we use the human feedback, but we still go with the reinforcement learning, and we use of course, as long as we talk about the reinforcement learning, there is the reward function and the reward factor here. We just shape the reward mechanism thanks to reinforcement learning, which is already produced by the human perspective, but we still somehow eliminate the algorithmic mechanism of this learning stage by feeding the system with the human feedback. So in this way, we try to ensure that reduce risks and increase the level of the trustworthiness in the agentic AI systems. Okay. So another example, as you remember from the cloud, is constitutional AI. It's a more complicated and a very nice flow, actually. We have two different stages. First of all, there is the supervised learning stage, and it's followed by the reinforcement learning stage here. There's a helpful LLM. It ensures a red teaming. It gives some response, critique, and revision for the fine-tuned LLM. And it's the fine-tuned LLM generates some responses to the red teaming prompts, as you can see. I think I can also use my mouse at this point. So it just all generates the response to the red teaming prompts, just coming from the red teaming mechanism. And at this point, it asks the model just about which response is preferred. So the reward model is fed by the decision or the answer to this question, I mean. So it all helps to fine-tune the LLM with the preferences. So there is the constitutional LLM at the end, which is already a fine-tuned LLM, but it's all supported by the red teaming, which is led by the helpful LLM. So we still use some LLMs, of course, but at this point we use the supervised learning stage and the reinforcement learning, which is done towards the rewarding model to make our LLM model constitutional. So in this way, we try to increase the level of the trustworthiness in agentic AI systems. There are more things, more technical things, of course, in detail, but because of the time, I just wanted to explain briefly. So when we continue, we can also think about the safe learning or behavioral testing. It's a big headache, actually, another story, but the learning agent systems conduct trial and error while exploring their environment, the real environment, I mean. And also in the real world, these explorations can have harmful consequences, which are risks that we have already been talking about so far. So for better understanding the potential risks or the harmful consequences further, safe learning and behavioral testing can be done to agented systems. So this may require deep analysis and intense use of course, computational resources. This is the critical point here, which causes the big headache I indicated before. So also there's another thing that using explainable AI. We already talked about this today. I remember almost all, I think all valuable speakers before me talked about the XAI factor, of course, because it's very critical for ensuring the trustworthiness, of course, in the intelligence systems. Like we have techniques such as LIME, SHAP, or attention heap maps for the image-based models. These all can be used for the model explainability. And also, there's another thing special for the prompt-based systems, agented AI, prompt-based agented AI systems. It's all about the chain of thought prompting. So it also allows us to step-by-step logical explanations in LLMs. So also controllability and corrigibility is also another critical aspects here. The agented AI systems must be able to adapt to state chains and reverse incorrect behavior. So corrigibility refers to the systems able to stop when told to stop by a human. even when we talk about the value alignment, as you remember, I already said that value alignment is a topic which has some time, some past before the LLMs, before that the wind of the agented AI nowadays. So even that the corrigibility was another topic which I already saw some years ago. So there was some research works which are trying to establish some models, logical and mathematical models, just representing a red button, which is used to stop when an intelligent system starts to perform some harmful or unintended or unwanted outcomes in further time period. So it's all about corrigibility. So in order to ensure that updatable goal definitions and external intervention doors in the learning process, different mechanisms, different techniques are already have been appearing in the literature. So this is also another solution way for ensuring the trustworthiness in agentic AI. Yes, this is an example of an XAI. Actually, it's all, let me to like that ink here. It's all about the heat map. It's called as the class activation mapping CAM methods. It ensures some heat maps over the image, so indicating that your model just took a look at to these parts of your input image. So because of these regions, the parts it gave more attention. This result just appeared as the outcome of the model. So there are also, of course, some other explainable things coming from this research work. I think it was all about a brain hemorrhage or something like this, which was running on CNN. So this is one way, but it's not about agented AI, but just a basic way for the deep learning models. But when we consider the chain of thought, prompting, for example, it's a very basic example for this solution. Standard prompting may be giving some model output by just giving the answer to the question, actually. But when we consider the model input and the related prompting mechanisms on the background, an explainability can be ensured by feeding the output with some reasons, some sentences indicating the reasons why this model just reached to the that outcome in terms of that prompt flow. So you may say that if this will be enough, not totally, of course, but just a chain of thought prompting can be a good example of the catching the important points from the flow and feeding the outcome to the user side. And actually, the user side is very critical when we talk about the explainability in terms of not only agentic AI, but also for deep learning or even traditional machine learning models. Actually, for traditional machine learning models such as decision tree or basic regression models or logistic regression models, we talked about the interpretability, which is already visible from the exact mechanisms of the traditional machine learning models. But it's in time, it's changed the name to the explainability because of the black box level of the deep learning or hybrid machine learning oriented models. So it's another story, of course, but this is the way how the interpretability and the explainability is evolving in time for the user experience, for making everything safe and trustworthy for the user side. So this is also another solution for even agented AI. Okay, so another aspect is the regulative and societal perspectives. Let me to check the time. Yes, we have time. So there are the dimensions, like we need to talk about the regulations or lawful liability or societal values. So when we talk about regulations, I already talked about them. There is the European Union-based AI Act. There is the US side, NIST AI Risk Management Framework. From the OECD, there are some AI principles already reported or announced, I mean, in terms of a framework. And of course, in national level, there are AI policies. In even Turkey, we established the AI policies. I'm also director of the AI Research and Application Center. So I have been working on establishing a university site, the college site, I mean, the AI policy, which is already including some more aspects for the AI usage in terms of that, the publications or research or other aspects affecting the way of the research and the higher education, as you know. So it's also another thing, but the national level AI policies and the works in terms of this context are all related to the regulations. And so it's already applicable for, of course, agented AI. And also there is lawful liability. It's all the problem of the law, actually. So there are the ongoing national level debates, of course, but the European Union has the AI liability directive, and probably the US side and also the other countries trying to establish the nation level more directives or the documents or reports in terms of ensuring how to deal with the lawful liability in terms of the high level of the agentic AI applications for today and the future, of course. But except from this, when we talk about ethics and human values, it's more about the societal values. Again, there are national level reports, studies, and there's an IEEE ethically aligned design. You may check this one. It's a nice framework. Also, I liked about the NIST AI risk management framework, by the way. Already all of these, the frameworks by the organizations, worldwide organizations are very critical, of course. And as the standard definition, the IEEE is highly working on the different design perspectives and the standards. So IEEE ethically aligned design is another important thing in terms of the societal values. And of course, there is the UNESCO side. It's all has an AI ethics recommendation in terms of the societal values and the way of the agented AI when we compare with the human values and societal values and the technical aspects of the intelligent systems. So these three dimensions are all about the perspectives which can be accepted as somehow solution waves which should be followed by humans, of course, but we still need to do all of these things, except from the technical developments. They are not enough, as I've said before. Everything is ongoing among not only technical fields, but in terms of also societal fields. So these are the necessity in ensuring the trustworthiness level for agented AI in addition to the technical developments. Okay, so at the end, I'd like to talk about something. Actually, there are more things to talk about, but it may be another topic for the further sessions, which we can come together again maybe in the upcoming events. So I'd like to thank for your attention so far. So briefly, I'd like to say that the open problems will be all about the human error handling, as you know. So there's the big data factor. It's all affecting the way of the modern life, as you know nowadays. So agented AI is already established over the use of the big data already. So this is another open problem for establishing the trustworthiness in terms of the agented AI systems which are dealing with the big data, which has lots of risks in itself, of course. So value alignment I believe, will be always critical thing because the values, the human values, the global values, even cultural values always change. So the value alignment will be all affected by the way of the human values, which some values may be already all clearly defined and cannot be changed in time, even for the years maybe. But in terms of the changing conditions caused by the technical developments, is something like a paradox actually. There will be more different values in the future maybe, so the value alignment will be always a open problem for the agentic AI, or maybe the other AI concepts we'll be talking about in the future, or the AI versions. I mean, this will be always critical, the value, the human value, and its alignment for the AI systems will be critical. And of course, limits and applicability of XAI, explainable AI, will be always critical. And lawful liability, it's already a societal problem, of course, but how to establish these things into a technical aspects of an intelligent system will be always an open problem. And vulnerabilities in complex agented AI, it's all about the cyber security. I'm also have some research works oriented in cybersecurity. I give courses in terms of ethical hacking, and I know about the cybersecurity. I mean, not like my expertise level with the AI, but I know about the advancements and developments. So I can clearly say that the cybersecurity is now all about combined with the AI security or AI safety. So it's another thing, of course, AI safety, the hacking AI and other things like adversarial examples, the other stuff. There are lots of things ongoing there, but the vulnerabilities in complex agented AI will be all critical because it will be affecting the way of the cybersecurity in the future. And measuring the trust, how to measure the trust is also another critical thing. And trust among agents, different multiple agents, they need to trust each other, and how to ensure this is also maybe a subject to the measuring the trust. And simulations for trust and user awareness in terms of the human sides are all critical open problems. Okay, so some future perspectives I'd like to say is that the trust-aware AI may be a new future agented AI development. It may lead to mechanisms for the detecting the trust levels and ensuring calibrations based on user or human trust. So AI audit and certification frameworks, they are already appearing, as you already know, but in the future there will be more standardized frameworks that allow AI systems to be audited by impartial organizations and receive trust markets, of course. Or I already said that the cultural fairness, when we consider the cultural values, it's all about coming to the cultural fairness or more aspects when we compare the different cultures on the world. It's all a problem about the fairness and bias factor maybe for the future AI. So the future work may include developing AI systems which behave fairly in accordance with the different cultures, languages, and social norms. Of course, another way may be establishing global models of AI, of course, but I think it's a long time scenario, but the cultural fairness, catching the differences and ensuring a balance among them may be another better solution maybe, and a shorter solution for establishing trustworthiness in the future. And also corrigible AI agents. These agents will include or focus more the aspects that autonomous aspects that make them safely corrected throughout user intervention. So this will be probably another critical feature developments for the agented AI in the future. So there are more things, but I have the limited time, so your or ideas will be already welcome, of course. So I have an ongoing project. Actually, I'd like to also talk about this. It's funded by TÜBİTAK, which is NSF of Turkey. So in this system, I designed this system to be ensuring drug repositioning for the childhood acute leukemia. So it combines the different models like the graph neural networks and also generative AI models, but not LLMs, of course. It has lots of modeling for the drugs and also other aspects to ensure synthetic patients to be checked for the detected drugs. But especially last 2 years, I saw that because of the high wind of the agented AI, the established models need some more advancements. So I have 1 year to go for this project. So nowadays I'm trying to establish and combine or integrate the LLM models, the agented AI, into some aspects of the project by not, of course, changing the many things, but trying to include more trust level, more explainability, and more use of the LLMs and the user-based interaction to ensure a better outcome as long as this project aims to give a decision support system at the end. So I mean, why I'm showing this, you may already welcome to visit my project. It's also an introduction and an announcement for my ongoing project, of course. But the more important thing here is to say that the things are very changing rapidly, and the trustworthiness and the other aspects, application aspects for the decision support systems and the AI applications are changing very rapidly. So we need to adapt ourselves to these things, to these changes in terms of our projects, in terms of our values and ongoing things which are affected by the technological developments, but mostly by the AI-based developments nowadays, of course. So still, we should be try to combine a good mechanisms among the humans and the AI-based systems. I mean, we try to ensure a good level of the human AI collaboration. So this is a necessity because the only thing which is not changing is the change, as you know, even from the in terms of the business fields and for the healthcare, as we already and the valuable speakers already indicated, the different fields are all under the high influence of the agented AI. So we still need to change and adapt the things for ensuring trustworthiness and user-oriented usability and better outcomes for the better future for the humanity. So these are my final words. Thank you very much. Your questions are all welcome. I'd like to stop my sharing. Yes. Be better to see yours and also get your questions, of course.
I have a question, Dr.
Yeah,
Kose.
please. Yeah, sure.
So, first of all, thanks for the very interesting talk and like so detailed different techniques for detecting trustworthiness. My question is there a metric or is there a number? Is there some way to quantify trustworthiness of any agentic AI system?
Yes, actually, I cannot remember a specific name of some metrics like accuracy or recall or F1 score, as you know from the already known maybe classification systems or the mean of square error or something like for the regression-oriented models. But there are some applications, some metrics to compare the decisions made by the agented AI and by the humans, but they still need to be further investigations to make them official metrics for testing the trustworthiness level of agented AI. For example, when it comes to explainability, we can still accept the explainable AI methods as one component for measuring the trustworthiness level. So we just consider that how the input and output connections are made, or if these connections are made correctly or safely by the model. But this is just only maybe covering some specific parts of the trustworthiness. For example, I believe we need to run further tests like maybe hundreds of people from different regions of the world need to be enrolled in the tests of the systems. They need to give some feedback. Maybe we need some transparency before making the agented AI applications commercial, but it's another problem for the commercialization of the products, as you know. But I mean, I try to explain that there will be more appearance of the human factor in terms of the trustworthiness evaluation. So, for example, in some of my publications, I included some experts at the end to give the model and make them testing the model and give some feedback in terms of not only surveys but also giving some feedback by using some specially designed interfaces, like for example considering the cancer-based diagnosis or medical image-based diagnosis. I gave some or developed some interfaces which are specifically used by the doctors to draw and to detect some important parts of the image. So we automatically compared with some algorithms, we automatically compared them with the explainability outcomes from the models, and so ended up to the trustworthiness evaluations. But these are made by us. I don't know, we cannot call them as with an official name maybe, but there should be some more official metrics, but not like accuracy or other metrics. But I can answer like this, yeah. Let's see.
Cool. Thanks.
You're welcome.
So
I think Dr. Karp also has a question.
yeah. So
Yeah.
you're talking about trust, and you have some AI agent or agents working on your behalf. How can you control that they will only interact with agents that you have a certain level of trust in?
You asked that's how we can be sure about that the trust level is not changed in time, or just it's all somehow a
No.
desired level. Yeah.
No, looking at the screen here, I have you and I have Rahul, and I trust your agent more than I trust his. How can I constrain my agent to work with yours and not his?
Yeah. Yeah, it's a good question actually. So maybe it's somehow we need somehow consensus mechanisms, which can be something like I'm thinking about the blockchain. I just this reminded me to blockchain-oriented distributed system modeling actually. Maybe something like this, like a consensus-oriented mechanism, and calling the maybe many controller agents or some more user interactions which are having roles in determining the trust level of the specific agents in time while the system is running. It's the trust level is recorded and it's all specifically evolved and evaluated in time, and so it's somehow a distributed thing which is oriented a consensus based voting mechanism maybe. So it can be something like this, I mean.
Okay, but
I don't know.
there's no work going on that.
Yeah,
Correct.
yeah,
Okay.
actually, yeah. But this can be a good solution, I believe. I don't know. I've tried to remember that the literature just have some debates in terms of, yes, the trustworthiness, the how to trust the agents, or the how to ensure the trusts among the agents, as I already indicated in my presentation. This is also another story. But maybe a solution can be in terms of distributed system modeling and ensuring somehow some security for them.
Well,
Yeah.
your trust in Rahul is different than my trust in Rahul, and so a global trust system isn't going to work. But I just wondered
Yeah.
if there was that kind of enforcing that kind of control on AI agents, and you gave me the answer.
Yeah, maybe. Like this, I mean, there's some proof mechanisms. Sorry that I'm always indicating to the blockchain aspects, but maybe some proof mechanisms can give some ideas. Like, I mean, some proofing mechanisms are established according to some proof of stake, for example, is another different version of the proof of work. So it's all about the value of the agent or the client in terms of the blockchain ecosystem, for example. So when we transform such an approach into the multi-agent based system, maybe a global trust can be all maybe awaited somehow with some proof mechanisms, but it's should be carefully managed and tracked against manipulations, of course.
Yeah, no.
Yeah.
My question was, given a trust system and AI agents that do the same task but have different trust levels, how can I be assured that my agent will use the one with the higher trust level, given that it's open-ended. I can't code anything into it to force it to do that.
Yes. Yeah. Maybe in time, maybe with some rewarding mechanisms in time, maybe I can say that, but it's the human factor which tries to establishing some trust, maybe in time for some agents, but in terms of agents, maybe the rewarding mechanism can be evolved. Yeah.
Maybe I just gave you an extra unsolved question problem that you can add to.
Yeah, I don't know if anybody has some idea about some ongoing research about this, but rewarding mechanisms can be maybe evolved or changed in terms of solving the different changing level of the trust perspective by the humans. Yeah, this is the human factor. Yeah, it's already a big problem in terms of the trustworthiness, which is taking us to that discussion here even. Yes. I will be taking a look at for this, of course. Yeah. It's a great question. So thank you very much for this.
Great question. Yeah, thanks. Yeah. Thank you, Dr. Kose, for a wonderful presentation.
You're welcome. Thank you very much.
Okay, yeah, so we have our next presenter who is Ranjita. So Ranjita is a senior ML engineer at Dropbox, and she is going to talk about defining agentic AI system, the capabilities and the path forward. So please go ahead, Ranjita.
Thank you, Rahul, and thank you, Professor Pendyala, for giving this opportunity and amazing talks so far. I will go ahead and share my screen. Please let me know if you can see it.
Yeah, we can see.
See it? Okay, awesome. Give me just a second. Right, do full screen. Okay, much better. Cool. Awesome. So hello. Thanks for staying on. I know this is like the last talk of the conference, so appreciate everybody's patience and waiting till the end. So we have seen really amazing, exciting real world applications today being discussed in healthcare, science, art, and everything else. We also saw a really high bird's eye view of agentic AI, where it's going, what direction it's taking, and so on. So I want to take a more zoomed in approach of how agentic AI is kind of implemented, what these systems look like, and so on and so forth, right? So as you all can imagine, there's an explosion of agentic AI systems today, right? And it's just only growing. Feels like there are as many types of agents as there are use cases. Now, if you ask 10 different people, well, four people that went before me all had different definitions of AI agents. But is the landscape of AI agents truly that chaotic? Or is there something fundamental that ties them all together, right? So at Dropbox, my colleagues and I first started building agentic AI systems around like December of 2022, when this technology was very much in its early days. And this journey has been one of discovery, trial and error, a lot of learning. And today I hope to share some of that experience with all of you. By the end of this talk, you should be able to, as any good agentic AI talk starts with defining AI agents. And we will get into understanding how we can categorize AI agents based on their implementation. We'll deep dive into some popular frameworks that are used for implementing AI agents. And we will we'll address some of the limitations or pitfalls of current agentic systems. And hopefully you'll walk away with some production insights that we have learned from building this kind of system in production and trying and testing. And in the end, I would love to leave you all with some calls to action, sharing some interesting research problem that could benefit the whole field of agentic AI. So, as you know, agents are defined in so many different ways. These are just like a couple, and then you saw all the other definitions from the talk this morning. This, in layman terms, is like if you bring it down to the corest of definition, what agents are is the current LLM-based agents, particularly, are LLMs with access to a whole bunch of tools and the knowledge on how to use them effectively. Now, to put this in words, this is how the common theme of agentic definition I would call out would be autonomously performs tasks with little to no human intervention. Right. So now this diagram is kind of loosely placed blocks, mainly because it will become clear as I go into the talk. These are all the components of an agent. So an agent, other than just the large language model, is comprised of tools that the large language model can then use. And there is this loop of planning, reasoning, and execution of the task, the tools, based on the user's input query. And there could be memory to kind of remember what has happened so far, and other storage systems where you can kind of track all the past interactions or what has happened in the current interaction, and so on and so forth. So an agent really is more of a system of these components. So now that we called it a system, do we have like a canonical agentic AI system? Would that be great? As these robots are attempting to all iron a shirt in different ways, there are many ways an agentic system can be implemented. Some might be more effective than others for the given task. There's no such thing, unfortunately, as a canonical agentic AI system. Why is it so hard to define a standard when it comes to an agentic AI system, right? It's just that there's so many dimensions. So it all depends on the requirements, all depends on the use cases of the kind of agents that you're building. So some may require very different set of tools, the level of sophistication required in the feedback loop, complexity, how deep do you want to plan, memory, state management, where do you want to execute your actions, and so on and so forth, right? Now, how do we make sense of this chaos? So I'm going to be proposing one possible taxonomy in this talk. That's not, of course, end all, but I hope it allows you to get some clarity in how we can categorize these agentic AI systems, right? So at a high level, if you look at it, any agentic AI framework, an agentic AI framework is something that may be used to define an agent, comprises of same sets of inputs and same sets of outputs. There may be some variations in like what the details are, but in the input, any conversational AI agent for that matter will have a query from the user. It'll have a set of available tools or functionalities or capabilities that this agent can use. And then at the end of it, the agent will come back with a response and probably sometimes share reasoning, right? So the core of it all, so these two input and output blocks are kind of fixed, but what we have more liberty to explore and experiment on is this block in the middle called agentic orchestration. So what I mean by agentic orchestration is basically this cycle of planning and execution to complete a task. Now, we ask the question, how does a particular agent orchestrate a task, right? So to define this taxonomy, let's consider these two definitions, steps and passes, all right? So steps, consider steps as total number of tool calls you would do per iterations. So this could look like if you make a plan to kind of complete a task, these are the steps in your plan. And passes is how many times you iterate over these planning and execution cycles to complete a task, right? So far, so good. So we have these definitions. We kind of classify agents based on whether they take single step and or multi-step. So in the single step, single pass block here, what you're seeing is just the basic atomic execution type of agents, also known as tool calling agents. What they do is literally just generate a single step plan and execute it. So you can imagine examples like very simple tasks like, calculator questions about, adding two numbers, subtracting two numbers, and so on and so forth. Those are tool calling agents. And when we go into multi-step, in this case, we're still staying with the single pass. What we're doing is we're generating a multi-step plan to begin with, and then we execute the plan step by step. right? So for example, in this example that I've given here is like book, flight, compare, and then purchase. So it's actually a workflow of sort, and it's dynamic in nature based on the input query. You are kind of building out a workflow and executing on that. So that's like a single pass, multi-step. And the next level of kind of complexity kind of gets added when we go into single step but multi-pass. So what's happening in these kind of iterative execution type of agents is you're generating a single step plan and you're executing it. And then you can observe and update your plan and then repeat this whole cycle as like a loop, right? So these kind of problems, these kind of agents can be very useful in solving problems that require, I want to look at the previous output and then take an action based on that, like exploratory problem solving at every step, right? And then comes the most complex or the most adaptive type of execution agents, which is like a multi-agent framework, which is multi-pass and multi-step. So you generate multi-step plans multiple times, you execute it, you update the plans again at the end of each cycle of execution, and then you repeat it. So think of cases like, software development teams or, AI teammates and things like that. So those are all multi-agent kind of scenarios. Now that we have defined a kind of an orchestration system, let's look at what are the trade-offs when it comes to these systems. As you can see, as the number of steps increases, the complexity of the task that you can solve also goes up. So you saw from the previous examples that as number of steps that you take increases, you can solve like more multi-step kind of problems, right? So something that requires a lot of breaking down of the input query into multiple steps and then executing it and so on and so forth. And similarly, complexity goes up as you increase the number of passes, because now you're kind of adapting every time you make a plan, you execute it, and so on and so forth. And of course, the trade-offs are latency and cost, as it's kind of pretty evident here. So if single tool call, just one call to LLM, and when you go into doing multiple steps or doing multiple passes, your latency slightly goes up, and cost as well kind of goes up. And the reason I'm bringing out these trade-offs is mainly because, like, if you want to implement something in an enterprise or a business domain application, you're kind of constrained by latency and cost as one of the most important metrics. When your users come, you don't want to keep them waiting forever, right? So it's very imperative to use the right kind of agents for the right level of complexity of your task that you're going to solve. Now that we have taxonomy, so let's look at some implementation landscape, how these vary across all these different frameworks, right? So different categories. So people might be familiar with some of these names. So if not, I'll just go ahead and explain those. These are some popular frameworks, and these are popular ways of doing things. So let's start with the bottom, the blue box here. Tool calling, it's literally just that. You make a prompt to LLMs. You ask the LLM, hey, these are a bunch of tools, pick from that. So a lot of LLMs can support something like this. Now, planned execution is something that we came up with, and a lot of other, we've seen other people kind of arrive at similar systems as well, where we generate a plan given the user query, and by breaking down the incoming query into like instructions, and I'll go into detail of all of these implementations per se. This is just a high level view of what each of the frameworks are in each of these categories, right? And iterative execution is where you kind of, there you have React, Codat, and you have a bunch of these like, kind of LangChain, LangGraph, those kind of agents. And adaptive execution, there are some frameworks here, and I just learned about the AI Explain talk from this morning as well, that these are the kind of frameworks that do multi-agent and kind of adaptive execution. So I'm going to kind of take each of these frameworks and walk through them in detail so that you can have a very clear understanding of how they work, and so that we can kind of decipher what is the strength and weakness of each type of framework. So atomic or tool calling, right? So consider a simple query like this. I'm keeping it very simple. It's very understandable. What is, 15 plus 27, right? So now, you can ask the LLM to do math, but as we've seen historically, LLMs weren't great at doing math. So what we came up with was basically providing tools that can actually do this. So we have like a calculator API, let's say, and then we say, hey, LLM, I have this calculator API, and this is the input query. I have all these other APIs. You ask the LLM, hey, can you choose a tool that is the best suited to answer this query? And then the LLM responds back. The example here you're seeing is like a popular LLM API. This is how you call most of the LLM APIs today support tool calling as a native functionality in their APIs. So you get back the tool call and then you execute the tool call in a sandbox environment or a Python interpreter, and then boom, you have the result. Right? So the core concept is basically LLM is the one that is making the choice out of set of provided tools. As you can imagine, it is very simple in implementation, and lots of LLMs that we have today have this capability. But of course, as it is apparent, we cannot handle increased complexity. Or even if like your number of tools that you want the LLM to select from kind of grows more than like, 5, 6 tools or something, it kind of starts to falter a little bit and it's not very accurate. And especially if there's some kind of overlap between what one particular tool can do. If there are like two tools that can achieve similar outcome, then the LLM can get confused. Now the next one is I want to talk about is the iterative execution or React framework. So in this, imagine queries like this. The query is like, what's the weather in Paris? Should I pack an umbrella, right? So now this example, what's happening is this requires a bit more understanding of the question before selecting the right tools and then executing it, right? So in a React framework, what happens is the first step is you ask the LLM to think about it. So it's kind of like borrowing the concepts from chain of thought reasoning. You're asking the LLM, hey, tell me what is the thought given this query, right? So before you take any action. And the next step is like the action itself. So the LLM will give back, hey, this is the API that we would want to call, and these are the parameters, right? And the third step is now that we have gotten this output back from the action that we took, what do we do with that information? So once you do this observation, you kind of go back and say, let's think about this. So there is a 60% chance of rain. So what should I do? Should I recommend the umbrella or not? So which was the original question that the user asked. So think, and then no more action is required because you kind of have all the details in that answer, in that thought itself. So final answer is then generated. So this is just an example, and you can imagine this can get more and more complex. It can have multiple steps, not just one action or one tool call. This framework is known for that. So reasoning, acting, and observing. This loop continues. You can do this endlessly until you converge on and saying it's like no further action needed. So as you can imagine, the strengths are, so we talked about explainability just before this talk, right? So it's kind of easy to understand. So you have the thought process, you have the chain of thought, you can understand, hey, what was the reasoning that went on when I got this answer back, right? But the weakness on the other hand is that it can be verbose, and people, it might be too much for like actually showing this directly to the user, right? Another thing is, as you can see, it's all done in natural language, and with natural language and English as a language itself, or any other language for that matter, it can be pretty ambiguous about what exactly the user means and what exactly are the actions that the system is going to take. So to kind of overcome that ambiguity aspect of it, this is another framework which is kind of, it lies between the iterative and sometimes multi-step approach as well, called CodeAct. If you have not seen this paper, please do go check it out. This has been implemented in some Hugging Face libraries called like small agents, and also there are open hands agents that are like used for software engineering. They all use this kind of approach. So the approach here is whenever a user query comes in, this can also be like multi-step, like you have to kind of break it down and understand, reason, and observe and stuff. It's very similar to what React did. Only difference is the LLM is not thinking in natural language, but it is thinking in code, right? In this case, it is Python, and we all know LLMs have been trained on tons and tons of Pythonic, data. So LLMs tend to do really well in terms of writing Python code. So what we're doing here is you write the Python code, you execute it in maybe a sandbox or environment, and then you observe things like, okay, did the code work? Did the output look good? So the observing cycle is still the same. It's going to observe the output or error messages and then take another pass if required to go and redo some parts of it, or write the next lines of code, if you will. Right? So this is basically the core thing is all the actions are expressed through executable code, and you basically think of completing any task as like writing a program, right? This is extremely flexible and can handle complex operations. What that means is basically the whole of Python is at your disposal. You can write any code that you want and whatnot, and then run it in an environment, and you can do data processing, file operations, all those things pretty easily by using Python libraries. But that also brings with it some security concerns. As Dr. Kose was talking about, security as being one of the important pillars here. It's not like if you go and tell your security team that we are going to run LLM generated code, they are not going to be happy. And it's basically saying that there is a potential of a lot of unintended malicious code being generated by LLMs, or sometimes even intentional when the because users prompt is driving all of this. So there is that security concern that comes over here. Now, let's move into this approach. This is something that we came up with, so I can go into a lot more detail while trying to explain this. What this approach does is it was basically developed mainly for answering business domain questions. And in order to do that, we have all these SaaS connectors that any knowledge worker in an enterprise might have access to. So what happens in this is basically two stages. The first stage is you generate the plan. So this is the planned execution that I just spoke about earlier. You generate a plan based on the user query. So let's take this user query. The user query says what's blocking our queue and OKRs, and when is our next planning meeting. So for people who are not familiar with the terminology here, let me explain. Q1 is basically referring to the first quarter of the year. OKR is objective key results. And so basically what happens is, let's say these are present in different multiple data sources. So data, what happens when it comes to enterprises, it's kind of fragmented across various different sources. And we abstract that away by saying, I have a tool that can go and fetch this particular data source. So for example, to break this query down, the first step we need to know is tell, hey, LLM, can we transcribe what this means, Q1 quarter, into a known type, as say a time period. What is a time period? Something that has a start and something that has an end, right? And we have helper methods that we give the agent, and we have some helper class and a helper method, right? And similarly, as you see, there are multiple steps that do exactly that. So the first step is finding quarter. Second step is getting the OKRs for the time block that was specified. And what are the blocking issues? And each of them has like a type and a method that uses the previous output or something that has happened, two steps down, two steps before, to get to the next step. So basically what you're seeing is execution of this plan would involve going through each of these and executing the code that is powering each of these tools, right? So now let's go into execution. Execution, the way we do it is actually keeping in mind the security concerns that I just talked about in the Code Act framework scenario, where basically what we are saying is we don't inherently trust the LLM generated code. What we do is first we validate. So since, as you saw, it was all like, typed and strongly typed, and like, so you kind of know exactly what the input of a particular, step is and what is the output. And this allows us to do some sort of AST validation. and we can kind of make sure that, okay, these helpers are fine, these kind of implementation is fine. And apart from that, we have implemented our own Python interpreter, which basically says it's a Python interpreter written in Python. What it does is it implements all the possible Pythonic methods that we think are safe, right? And if there is no malicious library that is available in your interpreter, it cuts down the chances of users input triggering this malicious pathway of, let's say I want to get the environment variable using the OS library, for those of you who are familiar with Python. So like leaking secrets and so on, that won't happen because we don't even have the functionality here, right? So plan execution has these security features, and also, but you might be thinking, hey, what if LLM kind of hallucinates, right? So LLM is going to hallucinate. Let me give that in writing. It's not going to be always like, it's not going to be always perfect. And also LLM is kind of restricted. If you say we have only these tools, right? I can only get blocking issues, but let's say it wants to get blocking issues for a particular topic, right? So how would it do that? So things like extensibility come with asking the LLM one more time, hey, you know what? This is the execution plan that we came up with. Can you go and implement some things based on these basic tools and functionalities that we have available in our helper classes, right? So LLMs are, as we discovered earlier, this is borrowing the elements from Kodak a little bit here. So you're kind of implementing this particular definition based on all the tools that are available. So for example, meeting helpers does not apparently have the get next meeting with title in time range, right? So this method can be implemented, let's say, by saying, by getting all the meetings and then kind of filtering by title and then sorting by time and all that, right? So that kind of implementation can be done in the second step of while during execution of the agentic lifecycle, and we do code generation to that, and then we execute it. So this allows us to be both secure and extensible, right? So what are the strengths of this? So this is extremely optimized for solving business domain queries. And we want it to be transparent in the sense, if anybody looks at the plan, they kind of know what went on. And we have a lot of validation in place, because a small mistake in your workflow can reveal really big problems if it is not secure, right? So that is like of the utmost priority when coming up with this framework. And the weakness though is that we kind of have to implement these custom helpers, and it's kind of less flexible. So it's a trade-off between flexibility and kind of how reliable you want your system to be in terms of security and transparency and so on, right? So the last kind of block that was there in the taxonomy, if you recall, is the adaptive or multi-agent system. So we saw a beautiful talk this morning on multi-agent system, and a lot of our speakers did touch upon this. So think of this as a composition of more than one agents. So the agents that we just talked about, those are all like very single agent architectures. Now you bring more than one of those agents and kind of build a system where they interact with each other. So the common kind of architectures are these hierarchical architectures. So organize it like a tree. So there's like a lead orchestrator agent, and then there are sub agents. Or it could be that there are other like kind of agentic frameworks that came about that said, we'll build a swarm of AI agents. So like peer-to-peer collaboration between agents and so on and so forth. So these are all, this is like a growing field of research, and every day new things are coming out here. And this is where most of the, highly complex use cases that require collaboration across multiple skill sets is going to be, with this evolution, it's going to grow. So now that we have all these classes, can we just pick one of them and say it's a standard agent? As you all know, the answer is no, unfortunately not. There's no silver bullet. It all depends on the task that you're trying to solve. Hopefully, the taxonomy kind of gave a little bit of understanding into what's out there and what is the kind of limits of each type of approaches, so that you can make an informed choice of picking one versus the other based on your use case. So let's spend some time talking about the limitations and how we've kind of overcome. What are the core limitations? So hallucination is number one, as you all can imagine, because we are dealing with LLMs here. So what kind of hallucinations do we see? We see like, calling tools that don't exist, non-existent APIs, or like there might be syntactical errors while writing these function calls. Then sometimes what happens is like overconfidently, like without verification, we kind of, if your agentic system executes, then that can lead to, hallucination induced errors. And correctness, of course, this is a thing, this is a North Star everybody is trying to chase. How can we get our agentic system to be the, most correct? Either it's accuracy or, precision recall, whatever it is that you're chasing for your particular use case. Now, and how do we handle edge cases? How do we recover from errors and so on and so forth, right? And the last pitfall is basically extensibility, because I hear this time and again from anybody who is working on agents to ship as an product, agent as a product. They are running into these issues. How fast can we scale as newer and newer APIs keep coming into the market? How do we scale? Or sometimes it's a problem of like, how do we scale when there is rate limits with respect to APIs, and how can we make our systems adaptable to those kind of challenges? So these are the three main ones. And in the next section, I would like to share some of our insights based on our experience on how we try to avoid these pitfalls. I wouldn't say we are like 100% there here, but hopefully this will give direction for whoever is running into these issues in their agentic implementations. The first one, and I cannot stress this more, this is the most important one, is eval-led development, right? So what does that mean? So the problem is like, I think most of you all have worked with ChatGPT or any other LLMs, right? So when working with LLMs, you have a prompt that's working beautifully. Some scenarios are working, but then you say, hey, this one scenario is erroring out. Let me fix it by changing the prompt, right? So you do some kind of prompt tuning, or like just hand tune the prompt a little bit. What happens is if you fix one type of errors, you will end up introducing errors in some other part of the system. So some other scenarios that were working beautifully well before now start failing, right? So why is something like that happen? Why does something like that happen? Is this build first approach, and this, like, I'm sure this is how most of us are building our apps these days in this era of moving fast and breaking things, right? So, but this unfortunately doesn't fly when your end users are like frustrated because your system performance is not consistent. Hey, this scenario was working yesterday, why is it not working today, right? So those kind of problems do come with build first approach. So what I'm proposing here, and this kind of, I think the whole industry is kind of waking up to this fact, is that we need to take an evals first approach, right? Start with an eval data set, right? Once you have an eval data set, it doesn't matter how complex it is, start with one, build your agent, you evaluate and make sure that, on the test cases that you have right now, you perform well. Then you deploy to users, and when you hear feedback, you kind of fix issues and stuff. And then remember, the most important thing is to update and rerun these evals, right? Now this updating process and fixing and updating and fixing, and until you are confident with it about threshold, keep doing this so that you have more confidence in the system that you deploy. Now how this has come to practice, right? So in a RAG system, like a lot of people have built RAG applications and that are in production today. How would people kind of tackle a system like that? You start with like evals on public benchmarks, public data sets. LLM as a judge metrics are pretty easy to come by. And then you build out, after you have like the initial set of evals ready, then you can build out more like representative data sets, gather annotations, maybe involve some humans to annotate, or then kind of learn from feedback of like, hey, our users are running these queries and it's not working, so add similar queries into your data sets. So, and then on these data sets, now you can run experiments like AB experiments whenever you want to make a change. and then you can make an informed choice. So there might be a case where, the most, loved feature of yours, you don't want to make any regressions on that, but there are some optional features which you're okay with making regressions on. So those kind of visibility, that kind of visibility will only come if you build an extensive multi-dimensional kind of data sets that will tell you, that will give you all this information when you run evaluations. So this is an example of how we kind of started with this. So we had like some public benchmarks that we got from, from like other companies that have published, which are like, free to use. These kind of public benchmarks allowed us to say, hey, these are all the LLMs that we have right now. How can we pick which one is the best in our RAG system? And these are the kind of evaluations we ran, and this helped us tremendously. Now, how does agentic AI system eval look like, right? So the current landscape looks like we have these tool selection metrics. So how accurate is the tool selection? How how precise is the task completion quality and all that stuff? So those two are the main things. And public benchmarks and leaderboards do exist, though they are very task-specific benchmarks. I'll get to that in just a bit in detail. And also, what makes this even more complex is execution environment. So like each type of agent requires its own type of execution environment, right? So you have some web-based agents, some APIs, local APIs, or mock environments, or you have a containerized environment, so on and so forth. So all these things add to the complexity of setting up an eval for agentic AI systems. So this is a publicly available benchmark leaderboard. So what this does is basically whenever a new model comes into the market, people run evals on this data set, and they publish results, and this is for tool calling mainly. And then there's also this one, which is more agentic in nature, the more meant for software engineering tasks, right? So things like Cursor or Copilot or Open Hands, all these kind of things can use these benchmarks to compete against each other. So though there are benchmarks, there is some kind of challenges, some gap in where we want to be. So each of these benchmarks is tied to a specific task. So SWE-bench is only for coding, WebBench for browsing. There's another one called Gaia, which is slightly more inclusive than those two, but that is also kind of limited to like very general tasks. So this is unfortunately not an avoidable problem. Benchmarks are tied to specific tool sets, as you can imagine. So if you want this input and this output, you kind of have to use that tool. So you're kind of stuck in that ecosystem a little bit. Although that can be loosened somewhat in the sense that, you don't have to have Gmail. You can have Outlook and Gmail both as possible email options, right? So things, we can generalize this a little bit, but for the most part, they are tied to specific tool sets. And the enterprise API gap is basically a thing that makes it hard for us, people like us who are building for enterprise. The APIs that we need are not really present in the public benchmarks that are available. So this makes them not representative of, also real world usage. So there are these 4 factors, right, that kind of make, we cannot just take the public benchmark today and, go and run evals and say that that is the best thing, right? So what are these? So complexity of the task. So public benchmarks tend to be slightly simpler when it comes to the complexity of the task, whereas in real world, user behavior is a lot more, like they can ask very complex, very ambiguous questions when it comes to when anybody's given a text box, right? And number of tools that we need can be high in the enterprise world. The types of tools that we use are also different. And user behavior, of course, is something that varies from product to product. Unfortunately, this is something that we cannot do anything about, but there is a potential, I'll talk about to how do we solve this problem, right? Now, so how did we implement our evals? So I am preaching on about eval-led development. How did we do it then, even though there are so many challenges when it comes to public benchmarks? So this is kind of like how our agentic testing framework is built. So an agent, as you can imagine, is something that has access to tools, and these tools are APIs, and these APIs are powered by some underlying connector data, in this case, like, some SaaS data, for example, so you have a set of emails or you have a set of calendar events and so on. So from the mock data, you can define an initial state and an expected final state, and given a user query, how well does our system do? You kind of compare the actual final state with the expected final state. This is very familiar to anybody who has done software engineering. This is kind of how you would write integration tests or end-to-end tests for testing your systems. So this is kind of how we went about doing it. And after the evaluation-led development is kind of understood, the next challenge I want to tackle, this is a bit more open-ended but really interesting problem of how do we handle the long tail problem. So you have now solved the common case, right? So you have a benchmark, you have a bunch of examples, you have solved the common case. What about corner case, right? So we are in luck because this is not something that is new to the world of software development. We've been doing this for decades. So let's consider what our options are, right? So option 1, graceful failure. So as you can see in this calculator app, it displayed an error rather than crashing my phone or giving me an incorrect answer. It said, hey, this is too long, I cannot do this, right? And the other option is this one, where you kind of make your system smarter by anticipating these common errors that a system does. And these are corner cases, right? Typos in this case. And by handling the common error by giving some tool like this, so which basically what it's doing is finding the nearest word that is more likely to be a query. Google's autocorrect is a nice example of this dynamic input handling. Now, how are corner cases handled by LLMs? Well, these two examples tell you in the first top right one, it's LLM has no qualms about predicting future. And on the left bottom, what you're seeing is it's trying to solve a puzzle, but not really solving it right. But very blatantly comes out and gives you the wrong answer, right? So the short answer to how do LLMs handle corner cases? Well, they don't handle the corner cases these days. But what these long tail use cases give us is, it is really important in a production setting when you're deploying an app to users. Let's say your common use cases are working fine. Your benchmark says 90% accuracy or 90% precision on all the questions that came in. Then what do we do about the rest of them, right? So the long tail use cases are very important, because if users see unsuccessful executions, they do tend to churn. They're like, okay, how can I trust this system if it can't do this one task? It was doing one task well, the other one not so well. So this inconsistency kind of builds this trust issue with the users, and that's why it's very important to solve this long tail problem. So I propose these two strategies mainly, and this is coming from very similar analogies to software development world. LLMs are non-deterministic, but agents or agentic AI systems, they don't have to be, right? Can we make our agentic system robust? One way of doing this is handling the failure cases gracefully. And the other one is, can we kind of overfit our system on the long tail cases, right? Let's talk about error handling first. Now, traditional software and agentic AI systems, if you can kind of put a comparison between these two, error handling happens by doing input validation. There's retry logic, there are circuit breakers and rollbacks and all those things to kind of recover from errors in a traditional software engineering environment. Whereas in an agentic AI system, the alternates would be doing self-reflection to determine if the model is on the right path more often. And if we realize that the tool that was selected was not the right one by saying, hey, there was an error, then can we do alternate tool selection, do it again? And if we are not able to do it, we've tried multiple times, then you do graceful degradation by sharing what we have achieved so far and with helpful error messages. And in the worst case, you do human escalation saying, hey, you know what, I need your help to guide me further, right? So that is human escalation. So these are all possible strategies that we can use for error handling. This is showing one example where, you kind of catch the tool call error, and if it's early in the process, you try an alternative approach. But if it's later in the process, you kind of say, you know what, this is a partial success. I found this information, but I did encounter some issues. So here it is, so that you're not like leaving your users completely, hanging, and let them have some intermediate, response so that they can continue working on the problem that they were. The second one, and I tried to come up with a name for this, and I think right fitting is probably what describes this best. So what we're trying to do is, we're not going to like overfit a model like as in our machine learning, terms, but we are going to teach, we're going to handhold agents by telling them these are the corner cases. Next time you see a corner case like this, handle it in this way, right? So this is kind of how we can make our agentic systems much more deterministic. And some strategies here. So first strategy I'll walk through is few shot prompting. So let's walk through an example and then we'll come back to this, right? So this is an example of a DSL orchestration framework that I told you about earlier that we came up with. So this is a set of examples that kind of define this particular agent. In this case, as you can see, this is a calendar agent. It should know about your calendar. It should understand time period and so on, and get your meetings and answer your questions about your meetings, right? So now this calendar agent, this was like a setup where we had only Tuesday as a possible day in all the examples that the calendar agent had. We expected that the LLM should know how to change it if the query comes in as some other day, right? But let's ask this question saying, what are my meetings on Friday? Which is very similar to the previous example, but only the day changes. Unfortunately, the LLM started hallucinating and saying, because it has only seen Tuesday so far, it thinks, okay, get time period. I just have to run this method at all times, right? So this is a very clear case of hallucination of trying to call the wrong tool. Now, how do we fix this with right fitting? What you would do is you can go and add an example saying, hey, let's guide the model, guide the agentic system to handle cases like this. So I will just, literally implement the Friday example and write it down there. So now with this, what are my meetings on Friday is working well as expected. But not only that, we have now, it'll start working for Thursday, Wednesday, Monday, and all those things, because now you have kind of taught it a pattern to look for days by just adding one example of a corner case, which it has not seen before, right? So this kind of right fitting with few shot prompting has shown to help take your system from not just benchmarks, but high accuracy on your benchmarks, but also kind of going forward in your long tail scenarios. So you can do this very like in many approaches. Of course, these are just two I'm proposing here. So few shot prompting for React, it looks like some chain of thoughts that you kind of give more and more reasoning traces that you think are the successful way of doing it. Kodak, you can probably implement helper function saying it doesn't have to implement something. Maybe it's always getting wrong, something like, getting meetings, it's always getting wrong. So just implement that tool, right? Why do we have to rely on LLM generating that tool? Because if it's frequently used enough, we're going to implement it. And same thing for DSL orchestration, give it examples as I showed, and also implement anything that's super complex, try to implement it as a tool and use that as in few shot prompting so that your agent knows how to use that. And model improvements is another thing that we could do, which is fine tuning with some reasoning examples, right? So you take the LLM and you fine tune it with examples of how to do this right. Right now, the fine tuning has different approaches, and you can, based on what the quality you're seeing is, you can choose either like a reinforcement learning based fine tuning or a supervised fine tuning, depending on the error patterns that you're observing in your data set. So the bottom line of this section is basically make your agents robust by teaching them, hand-holding them on corner cases. And the other one is to handle errors gracefully. With that, we come to the last section of my talk, where I want to pose some future research problems to the audience here, so that you all take something back to go work on, or maybe the next advancements in these fields will come from whoever watches this. This agent benchmark problem, I talked about this earlier. Without benchmarks, without having something to measure on, you can barely make any progress. How do you measure your progress? How do you make how do you go and do your long tail handling? How do you go and quantify and make investments in areas where the system is failing? You can only do that if you have like proper benchmarks. So now some approaches I know this is a very specific thing that maybe all of us, whoever is building enterprise apps, to go and build their own data set, but there might be some generic approaches which are unexplored at the moment. So things like maybe build a fake worker that has all these enterprise environments set up, and like how they would interact, like synthetic data generation. The other one is like having a tool that generates benchmarks for a specific use cases, right? So maybe there's a tool that I can go and enter and say, hey, this is the type of APIs, this is the type of user, these are the type of queries. Can we generate synthetic data for something like that? The long tail problem, though I proposed a couple of solutions, it's not a solved problem, obviously. So how do we solve this long tail problem? How can we give our LLMs in our agents this ability to handle corner cases? How can we do better planning, better reasoning? And also again brings back to how do we build benchmarks for long tail problem solving. The third one is, last but not the least, it's called long horizon problem. So imagine a task that takes really long to complete, like multiple days or something, or it has 50 to 100 steps to execute. Now, how can we trust such a problem will be solved as we expected, right? So something, this kind of hints at reinforcement learning for agent training a little bit, and what is true long-term memory look like, right? So these are some interesting problems I wish we could all work on, and hopefully it inspires folks to go work on them as well. So just to recap, we talked about definitions of any agentic AI system, and we discovered a new agentic orchestration taxonomy. We dive into basically popular orchestration frameworks such as React, Codat, and DSL orchestration. And we learned some production insights on evaluate development and handling the long tail problem. And we identified some research problems that hopefully we all get to work on in the near future and solve and move this field forward. Thank you.
Thanks, Ranjita. Go ahead, Aaron. You have a question?
Yeah. So in any non-deterministic system, it's likely that you'll get the wrong answer, but it looks plausible. And I've done enough high-performance computing with parallel codes to know to run into that problem. I think with the agent systems, it's if not worse, maybe at least as bad. So how do you deal with that in production, especially?
Yeah, that's a very good question, and that is like one form of hallucination basically that happens quite a lot. So I think the reflection or the observing part of the pipeline is something that we need to invest heavily in, which can actually go and say, hey, this was the plan that we generated, this is how we executed it, does this make sense, right? And all of this kind of eventually points to how can we train our agent systems better. So we can do it one way, which is like doing few shot prompting and giving it examples of what are good, what is bad way of doing things. But eventually we might have to do a little bit more, maybe train the models with like saying with like reinforcement learning or something that can deter the agent from taking the wrong path. But yeah, it's an open-ended problem. It's a great question, but it's definitely, it's not a very clear answer. So in our system, the way we kind of dealt with it is this functionality. So it's a trade-off, right? So how much creative license are you going to give your agent versus how much reliability you want for the output that is produced, right? So if you're willing to forego on something like that, saying that, you know what, it's okay, we know the agentic systems are still in early days, let's fail more often rather than kind of hallucinate and show wrong answers, right? So I think that is something that a trade-off we can do at the moment, but I don't think a golden solution exists yet in that.
So in space flight, they'll do the same computation multiple times, typically with different hardware, and vote 2 out of 3. Since hallucination is relatively rare, would the same strategy help?
Yeah, actually, that's a great point, like self-consistency type of approaches, right? Yeah, so if
just run it 3 times, and if one disagrees, that's probably hallucination.
Right. So it's basically saying, yeah, that's what is like, we call it self-consistency, but the idea is to kind of build sort of a confidence. So that is how we would like calibrate a system. So how do you show what is the confidence level for performing a particular task? Is like you do it like 3 times and you say 2 out of 3 times we got it right. So that's the level of confidence. And maybe you can set a threshold saying, I only want to select 100% confident results to show to the user. But yeah, that's a great suggestion.
The tricky part is that, unlike in the spacecraft example, that all 3 answers will be different. It's just 2 of them will be right enough and 1 of them will be wrong. That makes it harder.
Definitely, yeah. So that brings to our, who is watching the watcher kind of question, right? So who is the one that is making the call? What is your judge model doing? How smart is your judge model to determine that it's actually a wrong answer?
Perhaps your judge model is not an AI, it's just code.
Yeah, perhaps. Yeah. Yeah, like clinical trials.
Okay, if no other questions, then thank you. Thanks, Ranjita, for such a great presentation.
Sure thing. Thank you.
Dr. Vishnu, do you have any final closing thoughts?
Yeah, thank you, everyone. It was a very good comprehensive coverage of the topic. We covered theory, we covered practice, and it was global. So I hope everyone enjoyed it. So with that, I think we can conclude the session. Thank you, everyone. We'll keep in touch.
Thank you.